And hello guys to another stream. In this stream, I really want to try out C++, specifically Raylib. This is my current Minecraft clone. It has ambient occlusion, all the inventory, it has zombies, it has skeletons. In last stream we gave the skeletons bows. We implemented the bow in our current stream. Like, we did a lot. And obviously the project has become extremely big and it has become a huge mess. It has so many files. It has an old renderer, a new renderer. It's a complete mess. And in last stream, when I was trying to implement the skeletons, I had a helpful viewer and he just noticed like the mess I'm in. And one thing he said stuck to me, and I was thinking about it, and he was like, dude, no offense, but your project management worse than a beginner. If I was you, I would have a bad project management just slows you down. And that got me thinking, what if I try Raylib? And here is Raylib. This is an older project I test just to test Raylib and a physics library. And here this just creates balls. Here this is an artillery. And yeah, this is just to test the physics. Here a custom physics library. But this is Raylib, this is C++. And another reason I want to do this is because like I hate Java with a passion. Like, absolutely hate Java, since like if I want to add to a vector something, like if I have a vector 3f test new vector, and if I want to say it's like to increase it, I cannot do like test plus some other vector. There's no operation overload. I have to call a function add, and here I cannot do like in C++ you can do these brackets. I have to do another new object, vector 3f. Like, it's a complete mess. There are ways to mitigate this, but I'm not interested in doing that. And that's why I really want to give Raylib a shot, especially because we'll be using C++. And another reason is because for C++ there are so many interesting books I want to read. I want to have C++ as one of my toolkits. Because here I have another Minecraft clone that is written in C++. And this clone I managed to optimize it quite a lot. And it has infinite terrain generation, it has a fog. This is, I really like this Minecraft clone. And in this Minecraft clone, I had like threads, a thread pool. You can make yourself a thread pool, mutexes, like, it was so fun. And I switched to Java since I managed to have a lot faster progress with Java. But times change, and I want to try to give Raylib and C++ a shot. I want to see what will happen. So how are we going to approach this? Currently this is my Raylib project. And I managed to create this very quickly, because this 3D grid has it by default. You just call a function. This sphere, you just call a function. The Minecraft Java clone was written in with OpenGL. I had to write everything from scratch. And with Raylib, it will be a much different picture. So how are we going to approach this? That's my question. I'll remove my custom physics library. I'll remove my old code. Or before that, let's do a commit. before moving to Minecraft. Let's do a commit. Now let's remove all of these. And another cool thing is with C++, I have access to CMake. And CMake makes it very easy to add additional libraries and to have all kinds of cool features. I'm very excited. We'll see where all of this will go. And my biggest problem with C++ was here in my C++ Minecraft clone, I didn't like how I have separate header files and CPP files. Like here I have camera CPP and camera header. Like this is really annoying. And I thought, and I got an idea. Why don't I, just for the start, have everything in one file, just for the beginning. And once a structure begins to form, then to create the separate files. I think that would be worth it. Really. Let's remove this code. I'll leave this commented out so we have it as a reference. Let's remove this code. Look at how simple with Raylib it is. You begin drawing, you clear the screen, and you just set your current camera, like the perspective from which you are drawing, and here you just say draw sphere. That's it. Like, I really love Raylib. Comparison to OpenGL. Draw grid, slices, spacing, okay. Sure. We've simplified it, and now it should be just empty space. Yeah, now it's empty space, and I can even remove that sphere. We can remove that sphere, and we can change the clear color to something else. Maybe to the clear color, sky colors. Here I have a couple of sky colors. I can use some of them. So here can I do 0, 0, 0, 1? Oh, I think it was like 255. Yeah, it's 255 is the max. So for the color, this is white, and I want it to be, let's do Minecraft sky color. Let's have it be the clear color, be the sky color. This, but from which biome? This is the plains, this biome. To RGB. So it's this. That's it. There, now we have the sky. We have the sky and we have this grid. This is cool. And what else? What else? So where are we going to go from here? Drawing sky color with a simple grid. Where will we go from here? Let's take this out. What's the type? It's like this. color. So let's define it here. Define sky color. But I want to do it like they do it. Like this. Sky color. Yeah. Now I would want to see where the positive x is, the negative x, the positive z, negative z, that's what I want to see. So Raylib has this helpful cheat sheet that will show us everything that we need. So let's look at the functions. This is window related, cursor related, drawing related. Clear background, begin draw, begin texture mode, begin blend mode. Shader management, screen space related. Huh, that's interesting. And here I have a set target FPS function. You know how hard this is to implement in with OpenGL? So I'm looking for, is there a way to see what the positive x is? Set random seed. Or more we're just looking around in the what Raylib has to offer before we move on. That's more accurate. We can take a screenshot. What? Logging system. Oh, this is very helpful. Memory management using internal allocators. Memory management. Compression, events, stop recording automation events, input handling, yeah, we could get update camera. Okay, here is the drawing. Draw pixel, draw line, draw spline. This is very helpful. Check collision. What? Textures. Man, Raylib has so much to offer. Text. Okay, here, draw line 3D, cube, sphere, draw grid. This is what we used. What else can we draw? Draw line. Oh, actually, we can just draw. Yeah, we can just draw a line. Yeah, we can do that. Here we can just draw a line, the start position to be like 0 0, the end position to be positive x. That's it. A color, a black color, and then one for up, positive y, and then one for positive z. Yeah. These are the lines. So here it's positive x. This is positive. Let's set different color. And can I set size? And this is the color. So X usually is red, Y should be green, and Z should be blue. And draw point, draw circle, draw sphere, draw ray, plane, grid, Raylib, line size, oh, there's another function, ex, 3D ex. What's ex? The thickness, let's do 10. And oh, it's a vector 2s. It's for 2D. Yeah, we cannot do thickness, but it's not that big of an issue. Okay, so this is my X. It's difficult to see. This is my Z. And up there is Y. Line drawing. Raylib 3D lines. Okay, doesn't matter. My what I want right now is to see where I'm looking at in my Minecraft, because this is extremely helpful. This is the first thing that I want. Here in my Minecraft clone, when I press F3, it shows me debug information. Here I'm looking north, here I'm looking east, south, west. And this is what I want. Because when drawing cubes, when drawing terrain, this is extremely helpful to have. Extremely helpful. And I do it based on where the camera is looking. Get direction looking at. This is how I do it. So come here. And we need also Minecraft itself. I'll just start it so it starts loading. Now, let me think about it. Let's make a function that returns a string. So string get camera look at direction, and so here I receive a camera 3D, and here what do I have access to? Camera field of view, position, perspective. Oh, whether it's perspective or orthographic. Target. Target it looks at. And camera up. Just that? How can I get the yaw and... Not the pitch, just the yaw. Raylib, camera, yaw, and pitch. Okay, Raylib doesn't know about that. We can play around with the target, so we can see if we are... Like I want this F3 menu here to know if I'm looking towards negative Z, towards positive Z, towards positive X, or negative X. That's what I want to have. This is extremely important to have. But maybe we'll just debug it. We'll just debug it here. And we can draw it, draw the values, draw text. At 0, 0, 16 black. Hello world. Let's just see if we are drawing text. I don't see it. Raylib, draw text. Oh, we can use this text format, sure. Let's do 20 and here 100. 100. Oh, because oh, it should be like begin 2D. Begin mode 2D, I suppose. Camera. Yeah, but it wants 2D camera, so what's the issue? Begin drawing. Okay, it's in begin drawing. Okay. Draw text, hello world. Yeah, now I have it. And here, let's increase the font. Yes. We are drawing to the screen and I want to draw text format. Now text format is this. Raylib text format. Is there a guide somewhere? Formatting of text with variables to embed. Okay, doesn't matter. Let's do X, Y, and Z of the test Z. And here, how do they do it? Percent float. Let's do percent float. Here like this. And see, can we get where we're looking at? So this is positive X. And this is my target, which is not normalized. What if we normalize it? Raylib normalize. Vector 3 normalize. So test equals vector 3 normalize. We need to include it probably. Don't I have vector 3 normalize? Here, test. Okay. Now let's see the vector normalized of where we're looking. So this is the X is almost 1. And here Z is almost 1. Here X is almost -1. And here Y is 1. And here Y is almost -1. And so from this I want to have text on the screen. Are we looking at positive X or positive Z? This is what I want. And how can we do it? Using our target. How can we do it? Let me think about it. So we have a sphere. We can simplify it into 2D. We can simplify it into 2D. We have this sphere. And why is the shape so bad? We have this sphere from the center. And let's say this is positive X. Useless. And this is positive Y. And how can we know that we're looking in the positive? So if, and where we're looking at is a dot. It's a dot, and I think this dot is on the, when it's normalized, like in our case, it should be on the edges, probably. Because here the radius is always 1. Sure. And if it's on this side, it's sure, this side is positive X. And this side is positive Y. Like from here, it's like this. It's like this. So here is positive X. positive y, negative x, negative y. This is what I want. This is what I want. So how can I get this? So let's say our point is here. This is the simplest case. So that would be 1, 0. And here it would be 0, 1. This is positive y. And what's this? This, this, and this. What are they? How can I get those coordinates? Or actually, can I get, like we could do a dot product, because dot product gives us an angle between two vectors. Between two vectors. And for example, I could do it between this vector, the positive x, and the direction we're looking at. So if it's here, it's 90 degrees. This is 90 degrees. And this should be... so maybe... so this is 360 degrees. And we have 1, 2, 3, 4 parts. 360. We have 4 parts, so 90 degrees. Okay. So each of these are 90 degrees. So this should be 45. So if I do a dot product of my vector where I'm looking and the positive x, if I get more than 45 degrees and less than like 90 plus 45, it should be up. Then if it's like more than this angle and less than this, it's negative x. We could do that. Yeah, we could do that. Dot product. Yeah, there's a dot product here. So we can do vector 3 positive x like that. Camera target. This is the camera target. And now we need the angle. Look at angle to be vector 3 normalize. Not normalize, dot product. Dot product of, and camera target, I need to ignore the y. Camera target y equals 0. I need to ignore it. And here let's do camera between positive x. Actually, I can do it like this. Camera target. We can do it like that, and we can output the look at angle. And let's format it a bit. 02.02. 02. Okay. Now, if I look at positive x, this is 1. The angle is between 0 and 1 actually. So towards x is 1. Towards z, positive z, it's 0. Towards negative x is minus 1. And again 0. And again 0 with the z. Let me think about it. It resets on the z. So negative z is 0. It goes to 1 and to positive x. And positive x to z goes back to 0. Wait a minute. So from positive z, it increases. And here it decreases. Wait, that's so weird. So here the values are the same. Minus 1. No, here it's 1. And here it's minus 1. Okay, from minus 50 above minus 50, below minus 50, it will be negative x. Then from minus 50 to 50, yeah, from minus 50 to 50. And then from 50, then above 50 to be positive x. Then from 50 to minus 50. String direction equals, so if let's draw text again. Let's see if we're drawing below it more. Okay. Direction. Let's have direction. Test. Character. No. Okay, let's just do like this. To get this. Yeah, test. Okay. Now, if it's from above 0.5, no, if it's, yeah, above 0.5. If look at angle is above 0.5f, direction to be positive x. If it's less or equal, let's say equal. If it's less than minus 0.5, it's negative x. So here it's positive x. And this is negative x. Now I want the z. Z is from 0.5 to minus 0.5 is positive. If 0.5 to minus 0.5. If it's less than and is more than this, to be positive z, else if it's what's the other case? This is positive x, positive z, negative x, and here it's from minus 0.5 to 0.5. From minus, wait a minute, wait a minute, this is, so here it was from 0.5 and it goes through to here, and here positive z, positive z, positive z. This should be negative z. So it's minus 0.5. It overlaps with here. That's an issue. It overlaps. Okay, we can do another thing. Here, look at angle x and look at angle z. This will be with the z-axis. Positive z. Like this. And then here the same thing, but for the z. Positive z. Here it's else if, and here else, and here else. Maybe like this. Yeah, this should fix it. Positive x, positive z, negative x, negative z. Yeah. Perfect. And here positive z and minus 50 is negative x. Perfect. And let's remove this, and here let's have it be like Minecraft, where positive x is east, positive x is east, positive x east towards positive x. So this is west, towards negative. And south is positive z. Positive z is south. And here it's north. Like this. Yeah. Positive x, south, west, south, east, north. Perfect. Perfect. Positive x, positive z. Negative x, negative z. Perfect. Now, let's make this into a function. This here. Direction, we return the direction. Here. And here we use the camera. Oh, it needs to be reference since I've gotten used to Java. Or a pointer. No, reference. And if and I want variable that's bool show debug information to be false, and here we toggle it on which key F3, on F3, and here if show debug information, we draw it, and by default it's false, and if I press F3 we see the directions. That's it. This will be extremely useful. Extremely useful. Let's commit it. Showing direction we are looking at. Perfect. Now, this is the most important part. The second most important part is I think it's pop-out chat. We have viewer. Man, this is so cool. Wish I understood at least half of the coding process. You have to keep in mind, I've been doing this for many years, let's say. So, like, if we look at what you have been doing for many years, you will be good at that thing. Because if somebody has played League of Legends for years, he will be very good at League of Legends. Well, depends on how he has played it. Like, I've played League of Legends for some time and I'm stuck like silver, so, and I quit it. So depends on how you spend that time, actually, if I think about it. Yeah, so now we get where we're looking at. This will be important when we try to draw cubes. So now, what is the next most important thing we need to implement for the Minecraft clone? I think it would be this cube mesh template, where using it I can easily create any kind of shape. Because here in Minecraft, we load models with JSON files. These JSON files. And this is the JSON file for the tripwire. It's a complicated shape that is created with cubes. All of these are cubes. This is what I want to abstract. This creation of cubes. And each one of these is the same. It has from, it has to, and it has description about the faces. Like which texture are we using and what part of the texture. And I had this in Java as this class cube mesh template, where I use it, for example, when creating the iron block here. It's from 0 to 16, so it's a full block. This is actually the limit for it. And I set up the information and I generate it. And I can extract, and this way I can extract everything needed for creating a mesh. So where is it? Here I can extract positions, textures, UVs, indices, colors. I can extract it and render the cube. This is the second most important thing we should implement, in my opinion. So we had where we're looking at, this was important. The second most important, I think, should be that abstraction. And how to approach it. Here it's just a class that has these fields that you... And I was reading Effective Java book, and there they showed this concept of a builder, where the class had a static class declared inside of it that's called a builder, and that builder had functions you could call that sets up all the needed information, and then you have a function build that actually creates the resulting class. But here it will not be of use, since here... let me think about it. Yeah, this class will already be created. And I just want to fill it up with the needed information. And the needed information is this from, to, the UV information, colors, whether we're culling sites, rotations, offsets for the rotations. This origin, maybe it's for the texture origin. UV2, this is maybe for the lighting. Then rotations, this is maybe rotation for the texture itself. This is for ambient occlusion, we don't need it right now. And this is the result. And then we have a clear function that resets all the variables. I want this inside of C++. How are we going to approach it? Let's do an attempt and see where it goes. We'll hide this. Let's do an attempt. So should it be a structure or a class? Like, the difference is structure by default, everything is public. We can start with a structure. Cube mesh template. We can define it. And how can we simplify it as much as we can from the start? So at a minimum, we need the positions. We need at a minimum the positions. What else? We will not use everything. Maybe textures. Yeah, this for the textures and the origins, I think. We'll ignore culling for now. Okay, let's have this from and to. Let's have a vector 3 from, vector 3 to. And can we simplify it to not have to input textures as of now? Yeah, can we just use from and to? And what else? So let's try to do, using it, a simple cube. Just like I did with the iron block. So I'll pin this for reference. And let's look at its usage. Here. And pin this. So I'll do this. It's from 0 to 16 on all axes, so it will be a simple cube. We can do this. We'll ignore culling. We'll ignore textures. This is textures as well. We'll ignore it. We'll ignore lighting. Sure. So we need to hit generate, which will prepare all the positions, etc. So it needs a method to generate. So void generate needs a method, and it needs to give me all the positions at least for the vertices. I have two options. Do I store them inside of the structure, or do I output them here? Maybe here as parameters to have reference to them and fill them up, to not have to create here. Well, how is this used? It's used inside of subchunk, I think. Here, subchunk, and it's used here, get positions. Here, I get the positions as an array. I go through all of them to change the positions to be relative to where the subchunk is. And then I add all of them. Then I add all of them inside of this list. So in C++, instead of a list, it would be a vector, probably. Since there I can add as many as I want. It can be a vector. And so when I hit generate, I could give a reference to the vector. Hello, Beetle Edward. Let's have it, as of now, here to be to store the data inside the structure. As of now. Here it's an array list, but it will... Yeah, it should be... It cannot be an array with... when creating a cube mesh, it cannot be fixed size array since we have culling and we're conditionally adding faces. We're conditionally adding faces. If it's a fixed size array, it's not that big of an issue since we'll fill it up to a point. We'll fill it up to a point. it will not go past that point. It has, at most, it will have 6 faces. Each face has 4 vertices, so 24 size at most. And I can just have an integer that counts how many faces we're dealing with. We could do that. And then when we hit generate, we can fill up that array. We can fill it up. And since it's the structure is public access, here where we create the cube, we'll have a vector here. Here for sure it should be vector, where we collect all of the positions, all the vertices. It will be a vector. And we'll have to go through the array up to the amount of faces we are dealing with and put them inside of the vector. The alternative is here if we are storing a vector as well, we can maybe just combine them. Like maybe vectors have C++ like concatenate vectors. Maybe they have some kind of, yeah, like here. Maybe this would be simpler. But the speed will be O of n, it will be the same, doesn't matter. And the other alternative is to give here a reference to the vector of all the positions, and having a reference, we will not need to store anything here and can just directly give it to the parameter. I prefer the approach of just having an array here. Just having an array. And the array will be for the positions, so it will be a vector 3. And how do we do arrays inside of C++? Like this, sure. And maybe we need a constructor equals, and then here can we do 24? I haven't used C++ in a while. Arrays. How can we deal with arrays? Oh, from here. So here 24. Is that enough? Is that enough? Probably. Yeah, okay. So it's like, it's 24 because 6 is the maximum faces times each face has 4 vertices. So I could have here like a static int max vertices. I don't need this. Equals 24. So 6 times 4. And here max vertices. This I would probably how how can I give a static integer of a structure value? Hello plus channel 2. Was trying to add ambient occlusion to your other Minecraft clone easy? Was it easy? The hardest part was how to each block, how to have information of the 20 neighbors around it. That's the part that took the most amount of time. And the other part was easy when I just followed that guide. Can I do like here const and 24? Yes. That solved it. Perfect. So we have the maximum vertices, and I want to know how many faces we have. Here by default it will be 6, since we don't have any culling. Sure, that's not an issue. And so here for the generating, and we need this unit cube, because it makes it easier creating the cube. Yeah, I want this unit cube. We'll store it here probably, I don't know. So should be const static vector 3 unit cube array of how many? So it's like 6 sides. Yeah, again 24. So max vertices. And can I initialize it here? Initialize C++ static field structure. Like, I know one way to do it is this should be in the header, and in the CPP file I can initialize the data, sure, but here I have everything in the main CPP. So in that case I'm not quite sure, but okay, we can try. We can do here like this, and unit cube to equal this. Can we do it here? I can open my other C++ Minecraft clone, and here we can look for static. I think I've defined static fields. Yeah, here. This, do I initialize it somewhere? Here. Const float equals this. So I need all of this. Let's suppose this will be enough, and here I need for the south, which is plus z, I need north, which is minus z. I need west, which is negative x. I need east, which is positive x. I need top, which is positive y. And I need bottom, which is negative y. That's it. And here some vector trees. 0, 0, 1. Let's make them zeros. Let's make them zeros. This is unit cube, and here it will be 1. Here it's all of them are ones. Here it's 1. Here it's 1, 1. The north side. Here is 1, zeros, 1, 1, 1. And now the west side. The west is zeros. Here ones, 1. And here 1, 1. Then the east. The east here is all of them is 1. And then here, and now the top side of the unit cube is, for the y of course, is just ones. Then here 1, 1, 1. And here it's 1, 1. And the unit cube is done. The unit cube is done. I was the developer of my Minecraft mod called Minecraft mod test for Minecraft alpha version or something. I think that C++ is not as easy as other programming languages. Yeah, it's not easy, and Java was a lot easier to do progress in Java. But with C++, a lot more is possible. You have control over everything, and I really want to see how far I can go using C++. I'm just curious, really curious. So now when we generate, I have a function that conditionally generates. Conditionally generates a face. Conditionally add face here. This is what we'll do. I'll remove the conditional since we don't have culling, and I'll focus just on this. So void conditionally add face. And here I have a start, which is just, it uses the from the unit cube, from where to go. So if it's the south, I give it a start 0. It's like that. So we can do a for loop. Plus 4. I plus plus. And here we need integer start. Now, in positions, God damn it. Here we just could, since it was a array list, we could just like use at, the function at, but here it's fixed size array, so this will not, we cannot do this, but we can change this to be current face, and we can have void clear function and current face to be equal to 0. That's it. And so here, we could say current face, and we will need to void next face current face plus plus, and here we'll do conditionally add face, and this will be 0. How many? 6. 1 2 3 4 5 6, and they were for 0 4 0 4 8 12 16 20, and here we'll do next phase, next phase, next phase, next phase, next phase. So this will be like 0 is here, 1 2 3 4, and here it's 5, and I'm not sure if should increase the current phase after this. We'll see. So current phase, but here this is 0, so 0. Let me think about it. So I need here vector 3, the vector of the unit cube, the vector of the unit cube, and here it should, let me think about it. No, let's put I to be from 0, and here to be I plus start. So here we could do current phase plus I, and here it will be let me think about it. So this is the unit cube, and we have the unit cube vector, the current vector, its x value, but we have a size. Where do we get the size from? Alpha is an older version from 2010. I guess I just love early Minecraft. I also like early Minecraft. I prefer it. I think what I'm seeing is rendering the face and or the lighting of it. Well, what you're seeing is me trying to create a cube, like abstracting away the creation of a cube so that we can easily use Minecraft 3D models, which are JSON files. Every 3D model in Minecraft is a series of small cubes. If I manage to easily render any kind of cube, like they do it here, we'll be golden. So what is size? How do we set it? I set it here. Okay, we need a size. A vector 3. I need a size. A vector 3 size. And here we can clear before we generate, and then set size to be and set the size to be 2 minus from. to minus from. Yes, and so here we have from plus let me think about it. So we have this multiplication. How can we, is there a function for that in Raylib? Vector 3 multiply. Vector 3 multiply. Multiply. Multiply v times size. Right? What does it do? v1 time. Yes, this is what we want. It's this part, and then we need to add from to it. We need to add from. And we need to divide it by 16. We need to divide it by 16 and subtract minus point f. Can we? Then v equals v minus vector 3 subtract value 0.5f. That's it. And so here this to be equal v. That's it. That's it. And so here let's generate we can generate it here because in the while it's every frame. We need to create it. Cube mesh template. We need to create it. And we need to set mesh template from to be zeros and 2 to be 16. Like this. Then we need to generate. We need to generate, and this should have the data for a simple cube, and it should have stored the information in this array. And so now in Raylib, how can we draw a custom mesh? Like in Unity. In Unity, there's a mesh class that you can give it positions, normals, colors, and it will draw itself on the screen. Do we have something like that here? Mesh. We don't have a mesh. Oh, here is the math library. Mesh. Upload mesh. Draw mesh. Generate mesh cube. It returns a mesh. What else? Structure mesh. Do we create the mesh ourselves? So here mesh, and what does it have? This structure. What it has? Vertex count, triangle count. It has a lot of information, but this is at vertices. I should fill this up. The text coordinates. Yeah, we want this custom mesh. So how can we fill up the vertices? Well, let's go over all the vertices from the mesh template, cube mesh template where we generated a bunch of positions. For int I equals 0, I less than I plus plus. So here it's actually mesh template current face times 4. So here how much will it be? Starts from 0, 1, 2, 3, 4, 5. Yeah, let's do next phase here. So it will be 6 times 4, 24. Yes, so here mesh vertices, can we do I equals mesh template positions I? Can we do this? And it's a float. Oh, we need each individual X, Y, and Z to give it. That would be very annoying. It needs floats. And vector 3 has 3 floats. I have to give each one of them to the mesh. Each one of them. So here int current float ID, and here float for int it's like this is equal I times 3, and here it's X, Y, and Z, and here plus 1 and plus 2. So it has all the vertices, and now having this mesh, can we draw it directly just with positions? Upload mesh, vertex data and GPU, and provide VO VBO IDs. Upload mesh buffer, update mesh vertex data and GPU for specific buffer index. Upload mesh, draw 3D mesh with material and transform. Oh my god. Unload, and here it's draw. Draw mesh. Yo, material and a transform. Interesting. Yeah, let's do draw mesh. This is interesting. Let's do draw mesh. This is my mesh. Then the a material. We need a material. Terrain material. We need terrain material and transform, which is a matrix. Matrix, transform. Let's do the identity. Hopefully that's the default. Let's see what happens, because we haven't given the material and matrix anything. Using initialize terrain material. Yeah, okay, we need to set up the material. What does it need? It needs a shader. Shader maps array. Okay, how do we create a material? It should probably require a texture, which I do have, but I'm not using. Load material default. Load material from model file. Load default material. Check if material is valid. Unload. Set texture for material. Set material for mesh. Damn it. Raylib custom mesh. How do they do it? Here is an example. They load an image and create a texture and unload the image, sure. And they create a model. How many models? 9. Load model from mesh. And here they generate a mesh. Generate mesh. Generate mesh custom. This is what we're interested in. Export it using export mesh. So here they go over all the models. They target the material maps, material map diffuse, texture. They set just the texture. They just set the texture. And create a camera. Current model. Generate mesh custom. Yeah, this is what we want. Unload mesh. Yeah, this is what we want. Yeah, so we'll follow this guide. And actually, first, we'll just use this generate mesh cube as of now, just to get accustomed to using models, textures, etc. And then we'll replace generate mesh cube with generate mesh custom. That's what we'll do. So we need a model. I'll comment this out, and here I'll make a model, cube model. I'll create a cube, which will be load model from mesh cube. Like this. Here they create a texture, and here they set cube model, materials, maps, material, map, diffuse, texture equals texture, and then how do they draw it? Draw model, cube model, let's do 0 position and black color, and it needs a scale, and let's run it. Yeah, we have this cube. It doesn't have a texture. Cube model, width and height and length. Now let's do it 1 everywhere to be unit cube. Yeah, we'll leave it like that, and I'll be right back. I need 2 minutes. Yeah, I'm back. Now, the question is why the model is dark. How the model is dark? I think they're obviously using a texture. Here, if we look at it, yeah, here the cube, sphere, hemisphere, cylinder, all of these, they're using this texture. Here they create the texture, generate mesh cube, and here they set the materials. Sure. Camera position, current model, FPS, update camera, is key pressed, right, left, draw. They clear the background. They draw the model. Oh, because it's, yeah, I need to do the white color. Yeah, that fixed it. Now, let's create a custom cube. Like they do it. And how do they do it? They create a mesh. Oh, they allocate memory for the mesh. And here the vertex, normal, and text coordinates. Vertex, normals, text coordinates. And here, this is just one triangle. Okay, so it's the last model. Custom triangle. Yeah, just one triangle. This is what we need to use. It's good that we found the reference. So here let's create a vector of vector trees. Let's include it. Positions. How to use it? std vector C++. Now let's fill up the vector here. With this. Let's fill it up here. Positions. Push back. Mesh template. Mesh template. Positions. I. And we need normals. We need normals, so let's create them. And how did I make them? Conditionally at, and I'm not even doing it. Normals. I can have here vector 3 normals. Can have normals, and here conditionally add normals, and it should add 4 times the same normal. We can do it even here. Like, why not? We can do it here. Normals. Current phase. Here it should be current phase time 4. In here current phase time 4 plus I. To be in here the normal. And I don't know which phase this is it. Yeah, okay, let's do it here. Void conditionally at normal. vector 3 normal, and here do it like this. Add the same normal, and I need to rename this face. And here it should be the... And let's change it up. Let the north be first. West, east, top, bottom. Maybe even the top to be first. Why not? Like this. And so we need here this to be top. Top. Bottom. North. South. West. East. So top. Bottom. North is minus. North is minus. South is positive Z. West is minus X. And here positive. Okay, we have normals now. And we need texture coordinates. Vector 2 UV0. UV0. Conditionally at UV0. And and how did we do it? Add face, add texture, add UV2, add color. So here, add texture. Oh man. Origin. Let me think about it. So we have the origin plus the UVs and texture size. And then these are the coordinates. Bottom left, bottom right, top right, top left, sure. And then some kind of rotations. I don't care about that. We can have them be 0 and 1, 0 and 1. For each of the faces. So here we can have UV0. UV0 here to be zeros. Here +1, +2, +3. And here it's bottom left, bottom right, bottom right, top right, top right, top left. You can do it like that. It will use the whole texture for each one. And here, where? Here, we need more vectors, normals, and here UV0, vector 2, and then here we need to push back normals like this. This should be normals, and then UV0, UV0. And now we need to fill up the mesh, cube mesh, and let me think about it. We need to set up triangle count. Triangle count. Cube mesh triangle count. Can we use positions? Size. So this is how many vertices. And each face has 4 vertices. And each face has 2 triangles. This is triangle count. And cube mesh vertex count will be triangle count times 3, like that. And we allocate here memory, like they do it. Here, what do they do? 3 vertices, 3 coordinates each, 2 coordinates each, yeah. Like they do it, and now we fill it up. Now we fill it up. Now we fill it up. How? We need to go over each vertex is doing I equals 0, I less than positions size. We go over every vertex, and here we do cube mesh vertices I times 3 plus, here is plus 0, it's positions I, X, 1, 2, and here Y, Z. Now the same for normals. normals. And now the same for texture coordinates. UV0. It's here it's text chords, but for me it's UV0. Like that. And then we upload mesh, cube mesh, and then false. We upload the mesh, and then cube mesh, we use it here. We use it here. Now we should have a mesh. This is our mesh. For each side, it's drawing a triangle. Yeah, once we solve, at least we're uploading something and drawing something. But we're making somewhere a slight mistake. Let's create another model, reference model, load model from mesh cube 111. And we'll set its texture, and here we'll draw it at +2x just as reference, and let's set the camera position to be not that far off. -5. Target. Let's have target where we look at to be 0. Let's even have it be here. So the Y to be 0. And this to be 0. Maybe a bit more up. Yeah. So this is our reference, and we are a bit far off of it. If we manage with the custom mesh to generate this, we're golden. We'll be golden if we manage to do it. Following this guide. It could be possible. The only issue we have is the textures. Actually, can we execute render doc? Where's render doc? when you need it. We can execute render doc. Yes. So render doc. Launch. Now let's capture screen. Let's see what's up. We have 2 draw calls. If we ignore the grid. Let's see the wireframe mesh. Wireframe is bad. This shouldn't be so many. No, the wireframe is bad. How many vertices do we have? We have 36. And some of them are just zeros. We are not filling them up. Because I have 24. From 0 to 23, so yeah, I give it 24 vertices. I get it. So this is a mesh that doesn't use the indices. God damn it. Having this playing in the background while it's raining outside and I'm chilling inside is a vibe, to be honest. For me, it's also very bad weather. It rained a lot yesterday and it will rain today as well. Okay, so this is the issue. The mesh expects me to give it 36 vertices, so I need to repeat some of them. And in OpenGL in Java, I could use indices which allowed me to not repeat vertices. Can I do the same here? I think yes, if maybe it's expecting that information and I'm not giving it. Where's the mesh? Here. Do we have cube mesh? Let's look at the structure. Vertex count, triangle count. Vertex tangents. Colors indices, yeah. In case vertex data comes indexed. Yeah, this is what we want, indices. This is what we want. So let's do that. We need to give it indices. We need to give it indices. So here, let's have indices as well, which is integers. It's just in even you int 32, you int 32t. Yes. And what's the maximum? Each face, so it's max indices. It's here it's 6 times 4, and here it's 6 times 6 max indices. Indices is of bigger size. And we need to fill it up. Void conditionally add indices. And it's here, this. It's this, and then we need to fill it up. So indices current phase times 6 plus 0 equals 0. This is for one of the triangles, this for the other triangle. So it's 0, 1, 2, then 0, 2, 3. No, it's here it's 0, 1, 2, here 0, 2, 3, and here it should be 1, 0, 1, 2, 3, 4, 5. And this is it. And here I need a vector uint 32t indices, and here I need another for loop. Mesh template current phase times 6 I++, and here indices push back mesh template indices, but we need to offset them just like I do here in Java. So let's open subchunk indices. I need to offset them here. Now how do we do that? Positions. This is this is calculating the triangles, I think. No, this is the vertex count, which for the cube is 24. This is times 3y. Max indices. Let me think about it. Let me think about it. This is the vertex count for sure. And why do we multiply it by 3? By 3. So let's focus on one phase. One phase will be 4 vertices, and times 3 is 12. 12, and divided by 2 is the result of 6. Sure, we can leave it like that. It will be correct. And then we need this offset. We need this offset. for the indices. And now we need to give it here. And even let me think about it. A vertices count isn't like the vertices are not this amount. They're positions size. Yeah. And here it's we need to allocate for the indices. We need to allocate the indices, which is unsigned short. Unsigned short. Indices. Yeah, let's change the indices to be unsigned short as well. Why not? Let's keep the same types. Like that. And then we need to fill up the indices. So another for loop. Indices size. So cube mesh indices I equal indices I. That's it. It's not here. It's not here. Do we have error somewhere? No errors here. Yeah, I give it indices. Oh, I get it. Maybe the order is bad. What if we go here in the center? No. Let's open up render doc. And let's see. Wireframe. Mesh. Nothing. It has only vertex color, but the texture, vertex position is empty. It should be like this, actually. The position and texture coordinates are empty. And why is that? Oh, I'm not filling the indices. I'm not filling the indices. Conditionally add indices. I'm not doing that. And it started. And now we have a cube with textures that are probably bad. But the cube is drawn properly. Only the textures are wrong. Let's launch it in render doc. Was it crashing? Okay, it's working. Like this. And The wireframe is perfect. Wireframe is perfect. Now the texture coordinates 0, 0, 0, 1, 0, 0. Let's see it from here. So here, yeah, we're starting from the top. Let's look at more easier one. The bottom, the south. This should be the south. This should be the south. This should be the south side. And here we have positive X. Why is it starting from positive X? And the texture coordinates are from the left, and we are here from the right. Wait a minute, even the even the y coordinate is up, but we're down. Yeah, I need to fix up the texture coordinates. But wait a minute, man. So we are doing 0, 1, 2. So where's the unit cube? Here on the south, we're doing 0, 1, 2. But this is 0 on the X. That's really weird. And then 1 on the X. But in render doc, here it's on render doc, it's to the right. Why? It's really weird. That's really weird. We can simplify it and do just one face, the north. Let's just do the north and see what's up. This is the north, which is towards negative Z. Yeah, it's the north. This is actually the north. And let's see it in render doc. This is the north. Let's capture it. And I want to see the reference, how they do it. Here. They do from bottom left, top left, top right. That's how they do it. Then bottom left, top right. And the textures are, and the left is 1. Why is the left 1? And then the right, the texture coordinate x is 0. Huh. Okay, and let's look at our cube. How we do it. We do it from the right. So we start from bottom right. Then bottom right. Okay, let's try to match the textures. Here we add the textures. So it's current face times 4. So it's, and what are the indices? 0, 1, 2. 0, 1, 2. 0, 1, 2, and then 4. And what is the cube mesh here? This is the north. Yeah, it starts from the right. Then bottom left. Then left top. Yes, yes, yes. These are correct. These are correct. And now the textures. And now the textures. They should be... Okay, if this is 0. 0, 0. Then 1, 0. Then 1, 1. And they are not like this. Think about it. UV 0. Most likely the mistake is down here actually. Text chords 0 UV0x Y. There isn't an issue. UV 2 component per vertex. I'm sending one data, and in render doc I'm seeing some other data. Like here I'm seeing 0, 0, 0, 1, and I'm sending 0, 0 and 1, 0. And then it's 1, 1, but here it's 0, 0. And then it should be 0, 1, but at the end it's 1, 1. And that's a mistake. Why is that mistake happening? I have no idea. Why is that mistake happening? So here I add the faces. So from 0, 1, 2, 3, 4, 5, 6, 7, 8, 8. The north side. which is minus z. And here the north side, I add all of these four. Sure, I add all of them. And then what I do, I add the normals. I add the normals which are proper. And they are not shown here. They are not shown here. It's not getting the normals because it's not using them. That's why, probably, I assume. Yeah, it's just not getting them. Let's look at the array itself. The array itself is 2, 3, 4. I don't know why it has all of these. It's okay. Let's look at the array itself. It should be 0, 0, 0. Oh, why is 0, 1? Element. It's 0, 1, 0, 0, 1, 1. It shouldn't be like that. Conditionally at UV. Here it's current phase is 0, so it's UV 0, then UV 1, UV 2, UV 3. I fill it up like that here, sure. And here this is 0 up to 4, up to 3. And so here we go over, we push back. Maybe the push back method, insert element at end, sure. I push back them. And then here, why is it times 3? Oh, it should be times 2. Finally, I saw the mistake. Don't tell me that was the mistake. Okay. Again, just stupid mistakes. Now let's run it. And now we have a cube generated by ourselves. Finally. So let's commit it. Generating cube mesh. Now, what's the next step? Let's generate two cubes. Let's generate 2 cubes. So let's remove even the reference. Here, let's remove the reference like that. And here, let's do a for loop. X equals 0, x less than 2, x plus plus, and here we need to do this. Wait, what's the issue? These vectors should be here. And we do this. I'll have this cube mesh template also be here like that. And then here we generate it and we push back the positions, but we should add the X. Right? Like that. Yeah, this is a vector 3. Yeah, vector 3. Okay. And so we should have 2 cubes. We should have 2 cubes. Yeah, we have 2 cubes and we are not culling here. Here we are not culling, which is not that big of an issue. But we generated them. And now let's generate a lot more. Int y. Y less than 10. Y plus plus. Oh, it should be z actually. Should be z. And here let's do 10. And here float z. And now we have many cubes, which they are not culling anything. They are not culling anything. But it's really cool. Let's do 16 by 16 by 16, which is one subchunk. Which is one subchunk, and I think we can even do it like this. Like this. Yeah, like this. I think we can do it like this. And here y. And here y. Yeah, okay. My bad. Let's bring it back. Like this. Like this. Oh, again the same issue. What's the issue? What's the issue? Load vertex buffer. GPU is not ready to load data, trying to load before init window. Let me think about it. What's the issue? I'm trying to generate 16 by 16 by 16 cubes. So what's the issue? And I push them back to here. I create the mesh and here I allocate. I upload mesh, etc. And I have init window here. What's the issue? Return ID is 6. Load vertex buffer. Yeah, we should probably enable error reporting. Raylib report errors. Console log trace level custom logging. Set trace log callback. Custom trace log. Custom logging function. Yes, a custom function. Okay, let's do it like they do it. Let's do it like them. Like this. And let's capture any errors we get before init window. This is just inf. Yeah, this is just inf. God damn it. Exception thrown. Access violation. Reading location. Load vertex buffer. Do we have a stack trace? Call stack. Upload mesh. Here, upload mesh. Here's the issue. Vertex count is very... Oh, maybe we are going past some kind of a limit. Most likely that. Most likely we're going past some kind of a limit of vertices or maybe the indices since they are unsigned short. Unsigned short CPP limit 65,000. 65,000. And so here. How many indices? Yeah, look at it. 147,000. We are not allowed to do that. Yeah, that's the issue. That's the issue. We need culling. So here, how should we cull? Well, we need an array. We need an array that represents the data for one subchunk. Yeah. So we can make an array of integers, blocks, 16 by 16 by 16. Can I init it to zeros? And then for like impromptu terrain generation, to fill them up all, we need a void set. We need integer position to index, and here we'll get it from a vector 3 position. Here we'll return position x plus position y times 16 plus position z times 16 times 16. Position to index. And here we'll set x, y, and z. Float. We can do another overload int x, int y, int z. And here to remove this. And here to return position to index. Position x, position y, position to index, and here x, y, and z. And here, where are the blocks? Where are the blocks? Blocks here. So blocks 2 equal to 1. 1 will be that it's filled. And that's it. And here we'll have to look at the neighbors and set up culling. But I'll be back in 2 minutes. Yeah, this will not start, obviously. Is there an error somewhere? Yeah, I'll be back in 2 minutes. Yeah, I'm back. I'm back, so let's implement culling. Let's implement culling and integer cul equals 0. And we need some defines. Define cul top to be 0. 1, 2, 3, 4, 5, 6. Cul bottom, no, cul top is 1. North this will be south, this will be west, east, something like that. Let's check out how I do it. Here, so I do cul top is 1, cul bottom 2, cul here it's actually south 4, north 8, west 16, and here 32. That's it. And then we do here. We need to go over the neighbors. Calling. Go over neighbors. Like that. And let me think about it. Let's implement a class or like a structure. It doesn't need to be a class. Position details. And here I'll store, let me think about it. Should be how do I implement it? Position details. Do I use a float vector? Yeah, I have 3i. Yeah, I use integers. Yeah, we can do floats as well. We can do floats. Doesn't matter. Vector 3 local block position. Vector 3 chunk origin. Vector 3 block origin. Like that. And then we'll have functions. Let me think about it. We need a constructor, I think. We need a constructor. Position details vector 3 position. And here we need to calculate the chunk origin, block origin, and as of now we are not dealing with chunks. It's a subchunk actually. Subchunk. And right now we can say we just have one subchunk and origin is 0, 0, 0. Block origin. We can say like this is the global position. We want think about it. Because I'm looking for neighbors. I want the top, bottom, and south, east, and north west neighbors. All the 6 neighbors I want. I want all the 6 neighbors, and they can be in a different subchunk. Let me think about it. Let me go back inside of Java. Hey, I made it to one of these. What are we doing right now? Right now I'm using Raylib and C++, a brand new project, and I'm trying to draw Minecraft terrain. And right now I'm trying to draw one sub chunk filled up by 16 by 16 by 16, filled up with cubes. And I've managed to do that, but Raylib is not starting since I'm not culling the sides of cubes, so it has too many vertices and it has a limit of 65,000 vertices, and I'm sending like more than double that. So I need to set up culling, and for that I'm creating this class. This class will help me to look at, for each block, its neighbors, what type they are, even if the neighbor is in another subchunk, because the data for blocks is local for each subchunk, and we need to know where we are. Let me go here where we generate the quads, specifically for the ambient. Here. Okay, I give it the global position. Sure, it's not an issue. And here, what do I do? Sure, get block origin. Sure. Sure. Yeah, I need to calculate all of these. We need to calculate for each position what is the subchunk origin, the block origin, and local block local block position. I don't think I have used ever, but we'll calculate it. It's not that big of an issue. So the subchunk origin is equal position. I think we divide by 16. I think we need to divide it by 16. And to let's look at Minecraft chunk. Chunk position. Where is it? Floor. Here. Yeah, I need to get the floor of that. I need the floor. Actually, is there a vector 3 floor? I don't think so. Let's look at Raylib. Let's look at Raylib. Where is the Raylib reference? Here. Do we have floor? Oh, maybe the math reference. Where is the math library? Floor. There's no floor. Are you kidding me? There's no floor. Okay, doesn't matter. We can do subchunk. Equals math. Like floor, like this. What's the issue? Maybe need to include it. Math library. Quote math. CMAT, what was it? CMAT. And here maybe std floor. Yeah, or just floor. Yeah, so here I need to floor all of these values. Y and Z. Y and Z. Now we have the and we need to multiply by 16 again. Now we have the subchunk. origin. We have the subchunk origin. Now we need the block origin. Block origin is, yeah, let's look at the wiki. Chunk edges. Yeah, this is the coordinates for a chunk. And they had for the... Okay, let's just use our brain. If we remove from the position the subchunk origin, we will have the local block position, I think. And what is block origin? Isn't block origin just the position? Block origin. Oh, because it's a float, it's not an integer. Let's just round it. So block origin x equals round position x, and here y, z, and then local block position. Local block can be block origin minus subchunk origin, like that. Sure. Now the actually helpful part is some functions that allow us to move around easily. Where is it? There's a better wiki than the fandom wiki. Yeah, which one? I've only used the fandom wiki. There should be here, go up. No, this is the world. I need the position details. Position details here, go up like this. This is what will execute. Yeah, here, and it will return a position details. Go up like that. So think about it. We need to make a copy. How? C++ structure. We need to overwrite equals and not that equals. Yeah, operator equals overwrite operator CPP. Yo, hello Maskeli, you're from the previous video where we worked on skeletons. You were there for the whole stream and you helped me a lot. Bro, you sick, you sound different. No, I'm not sick. I'm just coding. I'm just coding. But thanks for the concern. Yeah, it should be like this. So, let me think about it. We need a new position details. Yeah, let's see the CPP versus the other kind of plus implementation. They did it there. They did it there. Yeah, here. This thing. Doesn't say it. Doesn't matter. Here. New position. The new position to be from this. Can I do it like that? And then here maybe position details, and then const position details reference order, like that. And then here to make the actual copy. Can I do copy? Order X, order local block position X, and then Y, and then Z. Now the same for the other coordinates. Local subchunk, and then this, like this. And here I want a copy. Copy constructor, I think it's called. CPP copy constructor. Reference to other. So maybe removing the const. Right now, before we were using, we were coding Minecraft in Java, and now I'm coding Minecraft in C++. And want to test something. Like I want to see if it's because I prefer C++ from Java. It's easier to, like, I think I can do a lot more in C++. Because here, look, this is one of my previous C++ Minecraft clones, and here I have endless terrain. I don't have that in Java. I can do a lot more in C++. That's why. But it's just for this stream. We'll see where this will go. Yeah, I got a chance to fix the project management. Yeah, because you mentioned yesterday that my management is really bad, and now I have a second chance to clean it up. You get me? Here I want to do a copy. Okay, here two structures, sure. Here, like this. Calls the copy constructor. This is what I want. Yeah, it's a constant. Sure. Structure B, C, sure. So here it's const. And here, no instance constructor. Dereference it. Yeah, now it works. Now it works. Also, you should first add debug options like developer tools and dynamic systems. Well, here in C++, I'm instead of using OpenGL, I'm using Raylib, which Raylib has all kinds of debug systems that we get out of the box. So we're golden here, don't worry about it. We're golden here. So here going up, you know you had waste 3 hours. You know you had waste 3 hours for a bow and skeleton. Well, that was the previous stream. Like, don't worry about it. Don't worry about it. That was the previous stream. Here I want to return going up, but for this new position here. So we want to go up. So the Y increases by 1, and we have to do a couple of checks. Subchunk height is 16. Here is 16. Yeah. Yeah. So we'll call it just a result, and we'll return result. And so here we need to check if result local block position dot y is at the limit. If it's at the limit, result, we need to change the subchunk origin 16, and then result local block position y to be 0, else result local block position y, and here every time the actual block origin y will increase no matter what. And let me think about it. Local block position y, if it's, we want to increase it. So this is 15. Yeah. Let's think about it. Should we create a subchunk structure? Structure subchunk, and here I want const static int size to be 16. So subchunk size, like that. Was the issue? No, it's actually like this. Like this. Yeah. You know, you had also please at least think a minute before naming a functional variable. Everyone else tweak Minecraft face. Okay, tweak game dev face. Think a minute before naming functional variable. Oh yeah, I'll think about it. This name is good enough. Result, like I could call it new position. Like it's fine here. It's fine. Result is fine. Yeah, this is for when we want to go up. This is for when going up, and the same we need for going down. Go down. For going down, it's go down. We need to check if the y is at its limit. If so, we need to subtract here, and this should be subchunk height size -1, and here we should decrease the y, and here we should decrease the y. That's it. And now for east, for east For going east, it's the same, but in terms of the x direction. Actually, we can copy going up for east. And here is the x. Yeah, it's actually... Yeah, it's the same. Yeah, it's the same. And now for going west. Go west. It's here the x. And then south and north. Where is south and north? Here. So south is like this. This is south. This should be Z. Should be Z. And then we need north. Go north. And here it's Z, and that's it. And what's up? Why is it only me and other person in this? Well, I don't know, you tell me. You appear like every 2-3 weeks. Then you go resting. Then again your 2-week Minecraft game day phase kicks in. You should still consider debug options like pivot points. Dude, yesterday's was so funny, skeleton army. I'm kinda just listening. Yeah, guys, don't worry about it. Like, we're just chilling here coding. Don't worry about it. And I want another version of these functions that do not return anything but change the actual object. And actually, let me think about it. Let me think about it. I need second version of these. And I'll need to make a slight change. So this should be void. They don't return anything. What's the issue? They cannot overload just on return type. Huh. Yeah, okay, it doesn't matter. I can deal with just these functions. It's not that important. Here we have all of this was so we can go over the neighbors. Details. So this is the current block. And we want... This is the current block. Are there like vector 3i? In Raylib? No. Can we do here another constructor that uses another constructor that just uses integers y and int z, and in here let me think about it. Think about it. So here it can be what I'm wondering is if it's like this, like integers, it's like they're from 0 to 16 for sure. Yeah, but they need to be with the increase of their position. No, it's fine. It's fine. Here we can do vector 3 sub subchunk origin, and this is just 0. So we have only one subchunk. And here we'll do this subchunk origin plus x, y, and z. Vector 3. Okay, we need to float them. No problem. Yeah. So now we have the current block. We need to get its neighbors. So here we'll get position details. Top neighbor is the current block. Go up. And then 1, 2, 3, 4, 5, 6. So this is the top. We can just let me think. We can just call it neighbor. Just neighbor. Like this. And I'll copy this. 1, 2, 3, 4, 5, 6. Here we'll go down from the current block. Here we'll go north, here south, east, west. Now we're going through the neighbors and we want to get the block type, which is an integer block type. And here we will just we'll just return blocks. Where are the blocks? Blocks here, this. So it's an int. Let's just get a pointer to this, and here get index. Where's the index function? Position to index. Position to index, and here it's the local block position, like that. And here current block. Even for the current block we need to check if current block get block type blocks. If it's 0, that means it's air. We continue, else we move on, and we need to look at the neighbors and fill up this call integer. Bro is the black magician. Where the ingredients? Sitting at desk. We just watching. Bro, you know, good old Flash games. Yeah, I know a lot of old Flash games. Just suggestion. Why not? Like there was the one 2D Flash game with fishes. It's called Fishy. There's another game, 2D Flash game of the Matrix. The Matrix, the movie, where you have two characters, you have slow motion, you can shoot with a pistol and the character like dodges the bullet. There are a lot of cool old Flash games. Just a suggestion, why not make a video like I remade this childhood classic in 24 hours just to test waters. I'll think about it. We'll see. Right now my focus is the Minecraft. Yeah, I'll save you. I'll save your suggestion inside of Excalibur. Where is Excalibur? Here. I saved your suggestion. So here. Now we are looking at the up neighbor. Here, top neighbor, the top neighbor, and here we'll have to do cull. We have to do the culling. Let's see in here subchunk, where we go over the neighbors. Here, top. Let me think about it. Yeah, we'll do this culling. We'll do that culling. So here I need integer neighbor type. It's neighbor get block type blocks, like that. And let's do a function that returns a bool should draw face. And here should draw face is the current block type int neighbor block type. And here if the neighbor block type is air, we should draw the face. And so here, where is it? Here, neighbor type. So if should draw face, and here int current block type equals this current block type and neighbor type. If we should, let me think about it. If we should not draw it, we should cull it. So here cull sides, cull faces. Cull faces will be cull faces or the cull top. That's it. And this is this is the algorithm. Top neighbor, bottom neighbor, bottom neighbor, north neighbor, south neighbor, south neighbor, no, excuse me, east neighbor, west neighbor, and I need to calculate the neighbor type every time. Go down. Here I go up. Neighbor type, yes. Like this. And here the culling. The culling, and here it's culling bottom. Here we call north, here we call south, here we call east, and here we call west, and that's it. And when we generate, we want to give it this integer of culling faces. Here integer cull faces. And here is where we actually execute the conditionally at. Conditionally. Let me think about it. It can be here. So how did I do it? It was here. Where is it? Here, this if, here, for the top. So if no, actually, let me think about it. You could set it so that for some blocks, you want to intentionally tell it to not cull. Yeah, I have to set that up as well. Here, integer cull north 1 2 3 4 5 6 south west east top bottom, and the clear let me think about it. Yeah, in clear we need to set them up here. We need to set them up to -1 by default, which means there's no culling. Right. And then let me go back here. North cull. Yeah, by default when we clear it to -1. Sure. And here default culling flux. Yeah. Yeah, and here void set default culling. Let me think about it. Or we could just have the default bit here, the actually set default culling. Like to enable culling for all the faces by default. And yeah, that's how I'll do it. That will be the default. So here will be cull north. And do I have access? The define is way down here. I need to bring it up here. So here, cull south, cull west, cull east, cull top, cull bottom, and then here, this is for, I should probably name it better, cull north mask. That's more appropriate because it's a mask. And Maskeli wants me to think more when naming variables, so I'll think more when naming. Yeah, cull north mask. Like that. So if this is negative, let me think about it. How is it in Java? Here. If it's -1, so we don't have a mask, this doesn't execute. So -1 means we're not drawing that face. Huh. And we'll do it like this. This is the top. This is the top. And now the same thing. For all the others. like this, and let's format them. This should enable culling, and let me think about it. And here we need we can do an int call mask equals like that. And here to be this. Here to be the same. To be the same, and here we set it to be the call mask top, the top mask. In here it will be the bottom. Here it will be north. Here it will be south. Here it's west. And here it's east. That's it. Is that it? And there's some other thing. When we are getting the where is it? Getting the block type. If the subchunk origin is different than 0, then return error. Like that. Like that. And let's test it. Build failed. Do you want to continue? Where's the mistake? Yeah, and before I continue, what's up? Bro is focusing to Minecraft over years. At this point, bro developed a Minecraft clone so much, Mojang might hire him. And they probably are not looking to hire anyone right now. And also, I'm in Bulgaria. They don't have an office in Bulgaria. It will be cool to work for Mojang, but it's probably close to impossible. What you hiding at your basement? Why your house is chopped? YouTube viewers when bro reads Twitch messages, bro talking to ghosts. I don't have anything to add to that. Does not take 3 arguments. Position to index. Why doesn't it take 3 arguments? Like this. Here. Let's move the subchunk structure above this. Above everything, maybe. Here. Yeah, here it is. This is one subchunk. And I think it's working without mistake, because if we go inside, it's empty. So we are properly culling everything. Yeah, that's awesome. That's very awesome. Yeah, that's cool. And now we can make another subchunk. If we can have two subchunks, then we can have a whole terrain. So here can draw subchunk with culling like that. And now let's move that code. Let me think about it. So here is where we let me think about it. We need to organize it a bit so that we can move on. Let me think about it. Yeah, let's actually create our first file. Sub chunk h and subchunk cpp, and then let's get this here, and then pragma once, and here include subchunk h like that. Yes, and we want to move the code there. Subchunk h, let's move it here, and here from the main. From the main we want, what do we want? It needs a position. Each subchunk, does it need a position? Yeah, it needs position. It needs a position. Void generate blocks. Block generation will be block generation. Yeah, it needs the blocks. It needs blocks, and it needs, this will be block generation. And what else? Yeah, I need 2 minutes. Yeah, I'm back. Now let's move this logic to separate files. Let me think about it. So here what do we do here? We go over all the neighbors. So we need reference, let's say, to the model subchunk model and mesh subchunk mesh. Let's do that. And here void generate model. Let's have that. And here we'll do let's take all of this, and paste it here, and we'll have a void draw where we just draw the model like that. And here, what about these ones? These are some globals. Curl top. How do we get access to this? We can make a global header. Globals. Pragma ones. And here we have all the defines that we can reuse. Here, like that. Include globals h, and then we want, these are the globals. And yeah, let's move the cube mesh template and the position details. Position details H, and add position details CPP, and then let's add cube mesh template, and then let's add cube mesh plate CPP, and position details pragma ones. Let's take it out. Well, this is the cube mesh template. And the unit cube as well. So inside this is here pragma ones, and here we take this up, cube mesh template, we put it here, and we need to include it, cube mesh plate header, like that. And then the position details, we need to get that. Position details here, like that. Now these position to index, where should they be? A static to the subchunk structure maybe? And this? So inside the subchunk here, maybe? And so here, here we'll reuse, let's rename this to subchunk mesh, and let's remove this. It should be using this. And then the model. Where's the model? This we rename like that. God damn it. Like that. Like that. And here we had the subchunk origin. Origin. This is the origin. That's it. And now when position details, let me think about it. Now we want in the main map to map of, yeah, we need a map because we need now a couple of subchunks. So CPP hash map, I think. Unordered map, we could use that. So unordered map, let's do that. Here and here, here, we could do unordered map. Subchunks, and it's a vector 3 to subchunk. Oh, why is it undefined? Unordered map. STD maybe. Yes. And here, let's look at this code. Map. Yeah, here it's reference to chunk data. Come on. Reference to chunk data. Like pointer to chunk data. We could do pointer to subchunk, maybe. And for let me think about it. This is all the subchunks, and for position detail here, when we want to get the block, we gave it a reference to the blocks, but now we had a limit to not go towards other subchunks, but now that's not the case. Now here we want access to the unordered map. We want access to this. Position details. We want access to this as a pointer, let's say. So we need to include it probably. Include like that. Like that. It can be a reference, doesn't matter. And here we want subchunk reference to it from subchunks. Now how can I find it? How can we use unordered map CPP? Here they iterate over them and print them out. Sure. Yeah, they just iterate over it. I want to access directly one of them. This is at. Yeah. So unordered map CPP, let's look at the reference. And this at function, where is it? At. It takes a key. And what's the return? A reference to the map value of the requested element. But what if it's not there? That's what I want. It returns the reference. Okay, let's do a check if it's there at all. Lookup count with bounds checking. Returns the number of elements. Finds element with specific key. Yeah, we want find. Where is it? Unordered map. This is the map. And then what does it take? It takes a key. Yeah, to find the key. To find the key. And if it doesn't equal, then found, else not found. This is what we want. We want to search for subchunk origin. And then here else like this, we comment this out. So if it is found here, if it's not found, we return 0, we return block type air. And here we want the subchunk reference is the search second. And here we want access to the blocks, and that's it. That should be it. And so inside of the main, and how we'll give access to it, let's think about that later. So here, yeah, here, let's create one subchunk. So vector 3 subchunk position equals just zeros, and then we create the subchunk. By giving it a position. Subchunk origin. By giving it a position. And so here subchunk position, and then we subchunk generate the blocks, subchunk generate the model, and no, we actually we need to add it to the map. We need to add it to the map. So can we do subchunk position to be equal the subchunk reference? And then here we want to iterate over all of them. Here they iterated. Here we want to iterate over them, over the subchunks. And then here, the second, this is the subchunk, draw. And this draw, let's make it lowercase. Why not? Draw. And that's it. We should have one no, actually. When we call it to draw, here, draw, no, when we generate the model, we need access to the we need global access actually to, where is it? To all the subchunks. Because instead we will have to give it around everywhere. Where are they? Main. Yeah, this thing. We need access to this inside of this function when generating the model. So one solution is to give reference here and generate model, and inside of here to give reference where every time where we do get block type. Here look at how we actually give it reference to the blocks. And inside of what things are you going to add next? Well, right now I am not in the Java Minecraft clone, so right now I'm trying to do the C++ Minecraft clone in Raylib. I want to see what it's like doing a Minecraft clone in Raylib. So now I'm rendering the terrain. That's what I'm doing now. I'm rendering the terrain, and here in position details, how do I get access to everything? Position details here. Get block data. How do I get it? Here. I get it from world. Then here. So can I do? Let me think about it. Let me think about it. Global access. I need this to be global. So maybe to create a singleton. Let's do world header file. And here structure world. And here to make it a singleton, how? here I've made classes singletons before, like the game maybe. No, let's look at the headers, the world. Yeah, everything is static. Yeah, everything is static. And the world CPP had a structure world data that is static. And world data had these. Let me think about it. Can't we do just like static? Let's do pragma once and do include unordered map, and here to have all the sub chunks. This inside of world, and then here to include it, and here to do world subchunks like that, and then inside of position details, when we need the block type to get world subchunks like that, and inside of here to remove the reference to the blocks. And that's it. And now we haven't this feels like watching Notch make Minecraft again. Well, Notch used Java, so there is a slight difference. It's a different experience. It's a huge difference in the experience using Java and C++, but now let's see what are the issues. Function uses which function? Bytes of stack. Main CPP. Oh yeah, here let's do a reference equals new subchunk, then the position. Let's do it as reference like this, and like this, and this should solve that. Now the other problems. Cube mesh template, we need to include it. Cube mesh template, we need to include it. What else? Which function? The main? The main. The main. Maybe in the subchunk itself, this. Maybe this to have it be dynamic memory. So we can do it like this. This to be the size. And here blocks equals new. Like this. And then we run it. We'll need to do deletions. Then void delete. Well, it actually happens in the destructor. subchunk delete like this blocks or something like that. Dynamic array CPP. New, and then yeah, just what we did. Okay, and this we need to delete this. And yeah, that's it. Why is it complaining of that? Yeah, the function is the main. Yeah, the main function uses 17,000 bytes of the stack. Where? If we remove this, does it solve it? No. Yeah, it still complains of that, so it's not the subchunk. Probably. Maybe in one of the includes. The world, maybe. No, it's not the world. Yo, hi, my bro. Hello, AAN7N9Y. Here this is undefined because we need include globals H like that. What else? Undeclared, so we need here position details. Here include subchunk like that, and here yeah, included subchunk. What's the issue? Subchunk size, yes, it's not a class or namespace name. Yeah, what's up? Him, can you say I'm here? You are here. I like your Aspirate video, but I think that's scary. Yeah, same. Your Minecraft is cracked. Yeah, nice. Thank you. What's the issue here? Here, this function, the main CPP. It's not this. It's not this. This function, main entry point, uses too much of the stack. We need to switch from the stack to dynamic to the heap. Sure, I get that. It's not this. It's not this. Int monitor, not this. This is not creating any stack memory like that much. Not even this, not even the camera, not even here. Let's remove this code and let's remove this code and try to run it. Yeah, let's even restart the whole project so it clears up. And see if it has the same issue. Yeah, now that issue is gone. That issue is gone. We just need to solve this issue with the header file. We need to solve the issue with the header file. What's the issue with the header file? Okay. Subchunks find. I like your videos. And bye, I gotta leave. Goodbye. Wait, where are you from? I'm from Bulgaria. Not but now. Yeah, I'm from Bulgaria. Here, what's the issue? Why I cannot... Oh, yeah, here it needs a key. It needs a key. Subchunk origin. And here, what's the issue? No, actually, no, I don't need this. And here, world, subchunks, find, subchunk origin. And here, end. And here, subchunk reference to the blocks. And this position to index. Now, how to get this? Position, we'll make it static. Position to static, so everybody can have access to it. Subchunk position to index. And here, what's the issue? Oh, I am from Turkey. Well, Maskeli is also from Turkey, and and there was somebody else also from Turkey. Everyone that says from where they are, they always say from Turkey. I haven't heard a different place. Have a great stream. I hope one day you become really big streamer and you won't forget me. Well, your name is hard to remember, Mr. AA-N7N9Y. It will be hard to remember. Yeah, but I'll screenshot you, and now I'll remember you. I'll put you here. I'll put you here. Now you're remembered forever. Next. No suitable user conversion from model to mesh. Oh, here should be the mesh. Should be the mesh. What else? Now it's just this. Just this. Constating integer 16 of the structure. Oh yeah, I get what the issue is. Here I include position details, and here I include subchunk. Yeah, I get what the issue is. Yeah, it's like a circular include, and that's a big no-no. And I only need this in the definition. Yeah, I'll need the CPP file. So let's get this, and we'll work this in the... We'll do this in the CPP. Subchunk CPP here, include. Need to include position details H, like this. Oh, this is in the subchunk. Subchunk H. And this is the... And here is the include position details H. And then This, I want this. I want to move them, all of these implementations. I want to move them. Here. And here I want to replace them like this. Like this. Like this. We need to separate them out. Separate them out. Separate them out. Like this. And here, the actual implementations. Like this. 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 No, as I think about, no. It should be at the name, I think. Yeah, at the name. Go west, south, go north. Here like this. Oh, and finally we can remove this. Actually, all of these we can remove and separate them here, and this will remove the problem. What's the issue? A linking error. There is a linking error here. There's an what is an initialized subchunk mesh? The mesh, we can initialize it like this. And maybe the model as well, like with 0. But that's just a regular warning. I want to make the game run. Think about it while I drink water. What's the linking error? Unresolved external symbol, unordered map. And where do we use it? Where do we use it? Nowhere here. Oh, it's from the world. The world class. We can do a static void init. And here subchunks equals new. Let's see how they do it. They don't actually do that much. There is no initialization. So what's the error? What's the error? Linking. This is the worst part of C++. Trying to solve these compilation errors and linking errors. Static. Okay. This is unresolved. Yeah, I have no idea. We can do something else. We can do it like I did it in here, world age. And in world CPP to have this structure world data. That's something I can do. So here, let me think about it. Yeah, to make this a class. Will that fix it? No? Okay, let's next step. We can do new file, world CPP, and here include world age, and here to have world data. Which is the unordered map, which is this. This, and it's not static. And here to have static world data. And in position details, here to get world data subchunks. Here world data subchunks. World. How did I do it? Yeah, it has a static world data. Sure. And that's it. Oh, I need to include. Yeah, I need to include it. Probably. Main. Yeah, I've included here. It's a static member. World date. Oh, I've called it just data. What about here? Yeah, world data. That's it. World. Static world data. World. Yeah, it just has some static members. World data, yeah, no world data. It has it here. Structure world data. Yeah, I don't know. We can we can just do one like public static void init and inside of here to do like void init, like world init, and here world data subchunks, like clear, like something, some kind of use, and then to call it in main. World init Yeah, but it's a compilation error. Let's check it out. World. Yeah, I have only access to init. Or maybe like it's like private or something like that. Oh, I can do a getter. Static. Or like, can I... Static. Yeah, let's do something sort of getter. World. Like reference to this. Get subchunks. And this world. And how should it be? World. Do I have to specify static? No. Here, void world like this. Not void. Here, and to return world data subchunks, and then main get subchunks. How was it before? World get subchunks like this, and in position details here get subchunks. That's it. What's the issue? Unresolved external symbol world init. Why? What's the issue now? World and where is it unresolved? Is it the main? I'm including it. I'm including it. Here it's complaining with this world init. Here it's static void init. And here, let's look in the sandbox. World age, static void create world. And here void world create world. Yeah, I've done this before. Let's look at references. Yeah, I just do world, create world. What's the issue? And I include it. Yeah, what's the issue? Is it because of the way I name the files? To be in uppercase. And here uppercase, and in main uppercase, and in position details I'm not including it here. World age. What's the issue? Man, sometimes when using C++, you just want to bash your head in a wall, man. Man, so annoying. I'll bring it back like it was. with lowercase names. Just want to render a subchunk, man. Let's try again. Yeah, it's a linking error. But why now? Here. Yeah, I get all the CPP and header files. That's not the issue. Let's add the include directory, vendor source, just source. Let's have an include folder. New folder, includes. Let's clean it up. Let's move them there. What's your issue? Globals, position details, subchunk, world, and let's do this. Let's do this. What's the issue? What are you complaining about? Yeah, this is working. 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 But the CPP files are vector 3. Cube mesh. Oh, include. And which one of these is it? Do we have vector 3s here? This is from Raylib H. This is from Raylib H. Do we have issues here? Let's first solve these. Raylib H. Then here. Do we have vector 3s here? No. Row 3, no. Here, no. What's the issue with this? Position details. Why is it complaining about the divide and the subtraction? Yeah, main. I'm using. Yeah, let's include Raymat. Actually. And that solves it. Okay, do we have issues now? Here. This is the subchunk header. Any issue? No, not Raylib H. Man, linking is so annoying. Type redefinition. Come on, man. Work with me. Type redefinition. God damn it. Yeah, most of this stream is just struggles with C++. Trying to combine different folders. Type redefinition. Don't they have some? Yeah, this Raylib page. Raylib page. And how is this happening? It should stop from here. Raylib page should have been defined somewhere. Remat. This is inside. Yeah, let's move this. Yeah, let's move this. So what if we clear it? Do we have, yeah, create definition here, like this. Create definition like this, and then generate. Let's just do it this way. Let's do it this way, here, and then this, then this, 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 and here, here, to remove all of this, to remove this, to remove this, remove this, and then here to include array math. What's the issue? Here include vector. What's the issue? We need to do the same for the subchunk. Subchunk CPP. This. And here remove the implementations. And then what? Cube mesh template not used here. And this is not used here. We need this here. Let's remove these and put them here. Here. What's the issue here? And include Raylib. And here was the issue. This for the world. What of it? World. Include Raylib. Include subchunk H. And then in world CPP. Include Raylib. It should have the subchunk include. It should have it. It should have it. From here. Man, all of these errors so annoying. Yo, what's up? I'm struggling with C++. A lot. Because here subchunk is undefined. And I include it here. Oh, maybe it's cyclical include. No, it's not. What's the issue? No, it's not look, it's not undefined. Yeah, let's just restart the project. To the engine sandbox. And even clear up CMake. Let's clear up CMake. And regenerate it. And now it should be better. What's this? This should include Raylib. Here. Include Raylib. Here was the issue. Yeah, it should be get subchunks. Should be get subchunks. What's this? Hash. This is probably the. What's the issue? Output. Let's look at output. What's the issue, doctor? Failed. Term does not evaluate to a function taking one argument. Template. What's the issue, man? Yeah, I'll be right back. I need 2 minutes. Yo, I'm back. I brought some food since we are live for almost 5 hours. I need to eat something. I just had something to eat. Since I hadn't eaten anything the entire stream, now we can go on for 10 more hours. Okay, maybe 1 more hour. Here most likely the issue is the compare function for the unordered hash map inside of the world. Here, this. I need to use... where is it? Unordered map. I need this compare hash. It's a structure. I need this. Let's give it in the globals. Or I don't know, maybe just the world. Just the world. vector 3 hash, or maybe here inside of Raylib vector 3 hash compare. Unordered map. Here I just do the compare. Vector 3. The compare actually, I can, the values are, god damn it. The values are floats, but I'm only using this for the subchunks, and subchunks origins are integers, so that's not an issue. But here I'm missing the z-axis. Yo, hello, AAA. Hi again. I'm still not, haven't progressed. Here let's do a z value. Z. And shifting. So unordered, let's see here. Unordered map CPP compare hash. GLM vec3. Yeah, but this is a vector 2. And I'm not using GLM, I'm using the Raylib vector 3. Yeah, and this is for, yeah. This is for 2 values. For a pair, I need it for 3 values. I need it for 3 values. Is there some quick example we can use? This will be our hardest task to solve, sadly. So we can use an order map. In Java, I don't have this issue. It's positives and negatives for all programming languages. This is the negative for C++. Ray math unordered map. No, this is for 3D, for 2D. I need it for 3D. Hash combination technique 3D. A vector. What's this? This is a vector of integers. And how do we do it? How do we do it? We hash each of them. Yeah, okay, we can do... Yeah, let's do this. Let's do this. Online. CPP. And let's see what happens. So we are doing int we are doing this and what's yeah, and here let's say it's like 12 on the x and 13 on the y, and what's this? No, this shift CPP bitwise operations. What's the shifting? I do an XOR, I think. XOR, yeah, it does an XOR, which if they are the same, they are ignored. Only the ones where we have difference. And what's the shift? Left shift? It shifts it just by 1 bit. So we could do a custom one. Here we could do another XOR and XZ shifted 2 times. Yeah, that's something we can do. And here, hopefully it treats the float as an integer. And here we can give it like this. And let's run it. This should be here. No. And oh, okay, should be there actually. Inside of... No, should be here. Yes. And here should be like this. And here it should be like this. Let's run it. Finally, man, finally. Finally it compiles. Finally it compiles. Finally. Finally. What a pain, man. What a pain. Just to compile everything. And now let's actually run it. Get subchunks. Here was the issue. Okay, let's do... Oh, it should be like this. Yeah, finally. We have the subchunk. Finally, man, finally. Where is the... Is it centered? Where is the... Oh, here. So here is the origin. Here. Here this is 0, 0. So the chunk origin is right here. It's right here. Oh, man. And now let's git commit. Drawing one sub chunk through abstract away sub chunk world singleton. Now, next, now we in theory should be able to easily create another subchunk. So here we need to go through all of them here and generate their model. That's separate. And here we need to create them. So let me think about it. And also for deletion here, delete the subchunks, because we do new. Every time you have new, you need to have delete, or you could use the smart pointer feature. So here I want to create another subchunk. Subchunk 2 will be on the x-axis. Here we make subchunk 2 and subchunk 1, subchunk 2, subchunk 1, and we do the same for the second subchunk. Now we should have two subchunks. Yeah, again the same issue, we'll see about it. Even he tries not to forget you. This is username makes easier to forget you. No, I'll remember. Look, I have him here. AAN7N9Y. There's no issue. There's no issue. Now here. Here was the issue. Is the same problem as before? No. Do we have two subchunks? We're looking towards. This is Z. This is negative X. Positive Z. Positive X. Negative X. So positive X, negative X, positive X, east, west. We should have a second subchunk. There should be one more subchunk. There should be one more. Just one more. There should be in total two subchunks. Here I create them. Then I save them, I generate their blocks. And I go through all of them and I hit draw. Sure. What's the issue? But I don't see a second subchunk. Or maybe... Yeah, let's look at RenderDoc. It will tell us everything we need. Here. Launch. Was it not launching? Let's try debug game. Yeah, okay. Now, let's hit F12 and see, do we have drawing? We have two draw calls. This is one. Oh, they are drawing in the same place. Oh my god. They're drawing in the same place. So when I here generate the model, here current block, yeah, this is the current block, subchunk origin, and here I need to add I need vector 3 global position. Or I could just reuse this one. I need to offset it here plus block origin. Yes! I have two subchunks. And they are culling the blocks. They're culling the blocks. Let's do a couple of them. Here, let's do this init does nothing. I can remove it. World init. Here we can do int x less than like let's do 10 subchunks or like 20. X plus plus, and here on the Y, and here we'll do this, subchunk position, and then subchunk like this. The position should be x times 16, and this should be z actually. Z times 16. Now we should have a lot of subchunks. We have error. Access violation, reading location, loud vertex buffer. Let's look at the call stack. Here, upload mesh. How many indices do we have? Max indices 3000. It's just 3000 indices. Yeah, I'll have to check on this. Please, love of game add skyblock mode. We'll see about that. Bro, I swear if you ask me, I'll do any pixel art you need, like for a week. Pixel art is not a priority right now. I'll have you in mind. Let me check. Here, when generating the model, I want to see how many subchunks we have generated. size 400. And these are the keys. 400 subchunks. And they have their blocks. Huh. Crazy. Maybe the issue is if they are like empty. Generate model. Yeah, I cannot draw it. You don't have to even think about it. I cannot draw. What's the issue here? I'm trying to render 400 subchunks. I'm trying to do 400 subchunks. And here I get access violation. Before I had this when there were too many indices. ID 150. Graphics API. OpenGL. What's the issue? Here. It gets access violation. Something in the console. Yeah. Console. What's the issue? It's just information, no errors here. Mesh uploaded successfully. Texture loaded successfully. Yeah, I have a couple of meshes which they are a separate vertex array object. But why is it having separate textures? That's my issue. Okay. Let's look at the textures. I need only one texture. Generate models. Here it creates the texture. Yeah. Let me think about it. We'll give the texture separately from here. From here, we'll give the texture. Like this. Yes. What's your issue? Oh, it has to be reference. Main. It will use the same texture. And let's look at the console. Now it only creates new meshes. So let's look at the info. Mesh uploaded successfully, and this is mesh 20, and after that mesh 20, and this is 82. Access violation. God damn it. Access violation. Violation. Because of initialized memory. Passing a null pointer, exceeding buffer allocation size. The buffer. Come on, man. Upload mesh. Here. Upload mesh. Which position? What's the subchunk origin? It's 128, 1112. 128, 1112. 8 and 7. 56th. So I go over all the blocks. Here it should be size. Why not? And then yeah, I look at max indices 3000, which the limit is 65,000. Like, it's enough. Positions 2000, 2000, 3000. Mesh template. Mesh template. Let me think about it. Mesh template. I could do something else. I could take out the cube mesh template, have it here, and inside of main to have it, and in generate model to reuse it. Here. Like this. See if that makes a change. What's your issue? Error. Let's go to the error. We need to include it. Obviously. Cube mesh template. Now what's your problem? It's the same error. It's the same error. Let me think about it. So it has positions. It's a different subchunk. It's not the same one. I'm reaching some kind of a limit. Subchunk mesh, vertex count, triangle count, vertices. Oh, maybe here where we allocate memory, maybe we have a limit of how much memory we can allocate. Does that make sense? Because for let me think about it. If okay, have an idea. If max indices equals 0 to return. Not continue. Because some subchunks don't have any data. What's the issue, man? Let's look at what data we are actually sending. These are the positions. These are the positions. You know what? Let's do something else. Let's do something else. Have an idea. Instead of sending the positions here, we could have them be, instead of block origin, local block position, and the actual, like, where it will be to be depending on the transform here. When we draw it here, to be, yeah, the position to be its subchunk position, subchunk origin. What's your issue? Come on. Let's open up this thing. Let's restart it. And let's open it again. Again, the same issue. And let's look at the data. Here, positions. Now positions are actually relative. Sure. Positions are relative. Sure, normals. Normals look fine. Normals look fine. UV0. UV0 looks fine. Indices. This is with the offset. Yeah, the maximum 3000. Yeah, let's look at upload mesh. Raylib upload mesh. Upload mesh. Isn't there any kind of Raylib documentation? Not a cheat sheet, but actual documentation. Hmm. Just want to find the function. Upload mesh. I want to find about upload mesh into a VO if supported in VBO. Okay, here's the mesh, and this is if it's dynamic or not. Have to think about it. Damn it. Have to think about it. What's the issue, man? Yeah, let's go back to inside of Raylib and look at the error. It's this thing, this function. So enable vertex attributes, position. Oh, this is the position. And each one has a VBO. So the position VBO. And these are the mesh vertices. Enable vertex array. VOID. Enable vertex attributes. And then mesh VBO. Load vertex buffer. And this is the vertex count times 3 size of float. Sure. And dynamic is false. And these are the vertices. And then here we get access violation reading location. It's trying to read a location. Where? So it has a buffer and the size. It has the ID. We generate a buffer, one buffer, we bind it, give it the data with static draw. We give it with static draw. And what's the error? And this is just for the vertices. Not current document game. Access violation reading location. For the ID. I'm confused. Okay, we can simplify. We can simplify. Main. And here we do only one subchunk. Yeah, only one subchunk works. Let's go for 2. 2 works. Let's go for 10. 10 subchunks. And 10 subchunks work. Now let's go for 20. 20 work. And let's increase my Y to be from the 16Y. So here 18. So we are up from above. Like this. And let's look. Let's have our target be positive X. No. Wants it to be like this. Like this. Let's do the positive Z as well. That doesn't matter. Towards negative, positive Z, positive X. Doesn't matter. We'll do 0 here. And now let's do, this is 20 subchunks. Let's do 30. And 30 fails. Is it every time? Which ID? 99. Why does it have 99 as an ID? This should be 30. Let's do 20. Yeah, 20. Let's do here here 30. Yeah, this 30. Like this it worked 30. What about like this 50? It worked. Like this 50 it worked. Huh. What about 150? Then it's an error. 407. Why does it have an ID 407? Man, I don't get it, man. Let's look at GPU usage. GPU. Memory usage. About 3.3 gigabytes, I think. No, 2.8 gigabytes. It's again at 2.8. It's because I'm streaming. Okay, we can do. We could set it as dynamic. This flag to be not, but it's static. I'm not changing it. That's not the issue. And this happens for the vertices. This happens for the vertices. And here, this becomes 150. Yo, somebody is raiding. We have a raider. The joy of coding is raiding with a party of 12. Yo, what's up? We can do a shout out. Shout out. The joy. Yeah, I gave a shout out. Now, what I'm trying to do here. Yeah, I'm drawing one subchunk. Sure. And if I draw two subchunks, it works. Two subchunks work. And I have culling enabled. So inside of it, they are invisible. But if I increase them to like 400 subchunks, Raylib complains with access violation. Yo, hello, the joy of coding. I'm not much active on Twitch. I mostly look at the YouTube, so I may miss some messages. Now, this is the only thing stopping me from generating terrain for the entire world. This is the only thing. Let me see. Here. Okay, let's simplify. I have the model, I have the mesh, and I generate the model here. Like I generate all this data, and then I upload the mesh, and then I load model from mesh, this, and that's it. A shallow copy of mesh is generated, passed by value, as long as struct contains pointers to data. Some values get a copy of mesh. Be careful. Yeah, it creates a model. Mesh count. Yeah, but we don't even reach here. We get stuck here. The cool thing about Raylib is we can see the entire code. Text coordinates are null. The text coordinates 2 is null. Tangents is null. Colors is null. Normals is not null. Texture coordinates is not null. But we get stuck. Here we get stuck for the vertices. We get stuck with the vertices. Enable vertex attributes, the positions. Yeah, we have positions. VBO ID, mesh, default shader attribute location. Sure. And this function is giving us problem. Load a new attributes buffer. New attributes buffer. What I'm wondering is, can we look up any kind of information like documentation, Raylib, since I'm only getting this access violation, reading location. That's the only thing I get. That's the only thing I get. And here, if we're going inside of here, it's like it's generating the VBO for sure, and we're giving it size of 49. Yeah, and we're giving it all the data. Is the size the issue? The buffer is the buffer. Oh, what? Yeah, let's go back to the error. Access violation reading location. Okay. 23 BF. Is it the same as this? 23 BF. Yeah, it's the same as this. 7960. No. No, it's 79, but here it's not 60. But maybe it's like like this should be the location of the first element, and if we increase it to go by 1, by 2, by 3, maybe we'll reach what this is, and maybe actually we can yeah, this is an array of floats, I think, and this is the location. Can I copy it? I have an idea. Hex to binary, maybe. Or like hex calculator. Or can we see the location like from this debugging place? Like to see the memory. Yeah, let's look at Twitch. Yo, hello, what's your favorite Minecraft version? Because only hear the OG Minecraft music. I can only use the OG Minecraft music since it's not copyrighted on YouTube. Yeah, this is the playlist I run. I prefer the old Minecraft, of course. The direction where Microsoft has taken Minecraft is like not the one I prefer. Can I want to see, like, okay, can we subtract this hex number and this hex number? I want to subtract them because they're quite similar. 79, after 79 is the difference. So we can just look at F00. We can just look at that. Convert. And then again and we can look at this. 79. I want to copy it. I want to copy this. 79. This. I want to copy this. And go to the browser here. What's this? Yeah, here, convert, like this. And now I have these two numbers, and these are in decimal, so I can subtract them. Oh, come on, subtract. 61, 24, and this we can convert it back. Decimal. No, we can. Let me think about it. It's having problem reading. It doesn't have access to this location, which is quite similar to the first element of the array. It's float array. How do we calculate the size? Here it's size of float. So let's divide it by the size of float. So on line CPP, I want to check something here. Okay, understand. Float test equals size of float. Want to see how much it is. Maybe 32 bits. Yeah, 4 bytes. 4 bytes. 4 bytes. Yeah, okay, so this is the location we're trying to access. And this is the starting think about it. The difference is 36,000. So this, can we can divide it by the size of float and multiply it by 3 when dividing. 3053. 3053. 3053. And so here, if we go back when we upload it, 3053, max indices is 6000, position is 4000. I should have enough space. I should have enough space. Where do I allocate the memory? Here. I do position size is 4000 times 3 times size of float. I should have enough. And so it's having problem here. Continue. Yeah, access violation, reading location, which is an element of the buffer for the vertices. Access violation. Yeah, let's read up on this. And specifically for C++ arrays. Yeah, this is the issue. Why would... Yeah, let's look up CPP, reading location. Valid array index for the array are 0 to 17. Yeah. So it's probably looking outside of the size. Because this number is bigger than this number. But why are we getting the exception here when we're not reading it here? This is just OpenGL. This is for for the GPU to handle it. We are sending off the data to the GPU. We are not trying to access it. What's the issue? What's the issue? And this only happens when I increase the amount of subchunks. Each subchunk has a mesh and a model. So maybe we could create the model, one model for the whole terrain, in each subchunk to be just a mesh. But the problem with that is when I draw them, I when drawing a model, I can transform it. Draw mesh. Can I do draw mesh? Yeah, I do have here a transform. And the issue is not with the models, it's when we upload the mesh. That's the only issue. If I have a very few amounts of subchunks, let's say meshes. If I have few amount of meshes, I don't get any problems. When I increase the amount of meshes, like the amount of subchunks, here at this function upload mesh, when it reaches here, so when it's trying to upload the create a vertex buffer object for the positions of the vertices, it gives access violation for the array. Which array? Here, this array, vertices. And here it's the reference to mesh vertices. So at some point I lose access to mesh vertices. Probably. Mesh oh. Let me check. Here. Subchunk mesh vertices. I allocate it. Sure, it creates, returns it. Yeah. And so I go over the vertices and I tell them they're these values, which are just floats. So it copies them. That's not the issue. It copies them and we upload. Subchunk. Subchunk has a mesh and it has a model. Is it because we're doing somewhere a copy? No. What changes when we increase all the subchunks? What changes? Where's the bottleneck? Generate blocks. So if I don't generate models, what happens? Nothing, because there are no models, sure. So the issue is not here, and I have generated the blocks, sure. So here I can do a limit here. Integer subchunk count equals 0 plus, and here if subchunk count is equals to 10 to return, or to like break only 10 subchunks. And we'll do here like 20 by 20. Yeah, and it has picked only 10 subchunks, and since we have culling, here there should be a subchunk, and that's why these faces are not drawing, only the surface. This is good, but the issue is when we increase them. Let's do 20 subchunks. Now 20 still render. Let's do 50 of them. And now it breaks. So here is the issue is, if we call, the more times we call this function, the bigger the chance we get a break. Because the number when it breaks is different. Like now 40 works. 40 is working. Let's look at task manager. Game, 57 RAM. What about the GPU? What about the GPU? I don't see an issue with the GPU. So 50 breaks it, so let's do 45. 45 works. Let's do 48. And 48 breaks it. 47. 47 works. Does it work all the time? No. This is what I mean. It doesn't work all the time, but maybe it depends on which subchunks it's trying to load. So we could go over like we could go over like this again with the limit of subchunk count, so that we're going over the same ones. Here we will increase them, and here we'll comment this out. Here we need access to the subchunk here, subchunk position. We need to generate model, and here we give it the texture. 47 should break it. What's the issue? And we need to give it the cube mesh template. Mesh template. Sure. Yeah, 47 breaks it. Let's try again 40. I want to see if I can, if it can break on the same amount of subchunks. Let's do 20. 20 should work. Yeah, 20. The 20 subchunks work. 30. 30 works. And 40 I think breaks. No, 40 works. Does it work every time? No. Okay. The issue is, the more times I call this function, generate model, the higher the chance open Raylib breaks. So we could, for example, split up the function so it doesn't do so many things at one time, so we can think about it. Subchunk, prepare mesh. Yeah, generate mesh. Yeah, okay. I'll call it here this function, rename, generate mesh. Generate mesh, and I'll create another function. Generate mesh. This texture, we don't need it here. Generate model. And we don't need anything here. And yo, hello, what's up? Maskeli, what's up? We'll have generate model, create definition, and here we'll do the upload mesh. Here we'll do it. And I need access to the texture. Like this. Like this. Access to the texture. And in the main, I just need to give it the mesh template. And now let's run it. See, there are no issues now. Now that everything has generated, that's when we'll run generate model. That's when we'll run it. Texture. And that solved it. That's, oh my god, that was so much work. That solved it. Ain't your usual stream time 3 hours? Wait a minute, you said Maskeli, well, very cool, man. Well, yeah, usually I'm 3 hours, but I really want to make I'm not satisfied with the result, that's why I move on. That's why I do more. I'm not satisfied. And today is like, what day is it? And today is Sunday. Sunday? I thought it was Saturday. Today is like chill day, so I don't mind. Yeah, okay. Perfect. Perfect. Now, now let me think about it. We can remove this like from the texture problem. How like fuzzy it is. We can solve this. But now we can save it here. Let's commit. What should we call it? Drawing multiple chunks. Sure. And then the fuzzy look. I need, for that I need, when creating the texture here, texture, mip maps, integer, mip maps level 1 by default. So 4 levels, this should fix it. Ah, no. Do we get the same problem? I thought we solved it. Oh, come on. I thought we solved it. Let's remove the mip map thing. I thought we solved it. God damn it. I thought we solved it. Here I generate the mesh. Yeah, I generate the mesh. We could generate it on a separate thread. Let me think about it. No, actually. And then to generate the model, we upload the mesh. We load mesh model from mesh and set the material texture. Oh, I get, maybe the there's a big chance the issue is the what you call it here, the this function. Since I did it on my own, we could do it like this, and here to make them like to make them into integers. Here I'll ignore the y coordinate. I'll just use the x and z because I know that works for when it's 2D. If that solves the issue, then my hash is wrong. No, it's not that. It's not that. It's not that. Let's look at the stack trace. Let me think about it. Here, generate model from here. Let's see the subchunks. We have all the subchunks. Second, and this is the mesh. We have the mesh. Some of them have a model. Let's go back here. Here. I want to see the mesh. Subchunk mesh. Yes, it has vertex count, triangle count, the vertices. This is just the first vertex. Texture coordinates. This is null. This is null. Null. I have the indices. VOID. VBOID. I'm using Godot, and when I tried place like 10k tiles at the same time, the damn engine crashed, which weak laptop issue, I guess. Bro is small saying cold, bro, nothing can make him angry. Got to go, I have to visit someone, good luck, thank you. Thank you. I really want to solve this, man. Okay, I have an idea. Let's look up Raylib custom mesh. Custom meshes. Let's look at custom meshes. We need more examples. Allocate mesh data. Triangle count times 3, triangle vertices. Oh, my bad. My bad. Yeah, some time ago I changed this. Subchunk mesh vertex count. Yeah, some time ago I made a change to this. Some time ago. Yeah, that was the issue. Yeah, my bad, guys. My bad. My bad. Like, think of a simple cube. A simple cube is has 6 faces, each face 4 vertices, so 6 times 4, 24. This is if you use indices. If you don't use indices, it's 36. Because it's 6 faces, each face has 2 triangles, each triangle has 3 vertices, so each face has 6 vertices, and 6 by 6 is 36. So we have 2 options to pick for vertex size, and I picked the lower one since I use indices. But as it turns out, it was too little space. Yeah. I figured it out. Now it works without issue. Yeah. Yeah, the issue is solved. Now let's commit it. No more what you call it, access violation. No more access violation. Now let me think about it. Now we could add let's go the main. Can we center the whole world? Minus 20 by 6, minus 10 by 16, minus 10 by 16, so the 0, 0 is the center. Why does it generate for so long? Yeah, now we're at the center. And now I want terrain generation. Oh, the mip maps. Let's try out the mip maps. This is for mip map level. I don't know. Doesn't matter. Raylib, textures, mip maps. Maybe I need to generate them. Mip map. Generate texture mip maps. Texture. Reference. Doesn't matter. Oh, it should be before this. Same thing, man, same thing. Generate map maps. Yeah. Let's move on. I want Minecraft Sandbox. Here, what do I use? I use this Perlin noise file. Perlin noise. So here at folder Perlin noise, new file, and we paste this. And so now in the main here. When we generate the blocks here, chunk generator, chunk generator. Let's look Perlin. Where do I use Perlin noise? Okay, get continentalness. Get top texture offset. Okay, where do I use this? Final references. Here, get block. And I do all of these things. Surface Y. It's using all of this. Want it to be simpler, but okay, we can copy this. And here, where? Here. We can do this. And here include Perlin noise HPP. What's the issue? Let's include vendor. Yes. And so here, what's this value? Like this. And now I'll use this for generating here, int like float noise, and this to be x and z plus position subchunk origin x plus subchunk origin z, and I need some examples. How much is it? How much is it? 0.02. Yeah, it's from -1 to 1, I think. It should be -1 to 1. Think about it. Let's make this a conditional if noise is less than 0. Here actually. If noise is negative. Yeah, noise can be negative, so it's from -1 to 1. And we actually need to reorder it like this and to calculate it only here. And so in surface level equals noise times how much? 10. But noise plus 1 divided by 2. Like this. And if int global y equals subchunk origin y plus y, and then if global y is to surface level like this, we set it to 1, else we set it to 0 like this. Why are you complaining? This bracket, yeah, okay. Yeah, we have a little bit of terrain generation. Yeah, we have a little bit of terrain generation. But it's very pixelated. Terrain generation. And so now let's use actual blocks. For that we need the texture. We need the texture. So we need to update. We need to update, what you call it? We need to update, where is it? We need to update cube mesh template. Here I need UV coordinates for the actual texture. Where is it? Cube mesh template here. And what do I need? The vector 4f's. This. I need this. This is what I need. This is what I need. Vector 4. North UV. South, east, west, top, bottom. Do we clear them? No. And how do we set them? How do we set them? Here. We set them here. We give them here. We use this origin. What's this origin? What's this origin? Add texture. South origin. Oh, yeah, we need that as well. We need that as well. That's the origin from where from the texture we should start. north UV origin. One. Yes. South, east, west, top, bottom, like this. And here we need conditionally add UV, but here we need as an argument conditionally add UV. We need, what do we need? We need a reference, a vector for reference to the UV and vector to reference to the UV origin. And we need to implement it here and use it here. So for the top we add top UV and top UV origin. That's it. Same for oh, I had this previous function. Yeah, I need to replace it. You're being replaced. Replacing. I'm replacing you. Yeah, that's it. So this is the top, this is the bottom. This should be the north. This should be the south. And this should be the west. This should be the east. And then now we need to write down the function. We need to write it down. Before it was this. It was very simple. But now it needs to be a bit more complicated. So here we could have a static float size. Static const float size by 256F, because the atlas texture atlas is 256 by 256. And then we can calculate floats. So float u0 equals origin x plus uvx. Of course, the name is different. Like this. Times size. This should be v0, u1, v1. In here, y, and here x, z, y, w. And what else? I need to actually implement them here. I need U0 and V1. U0 and V1, and here U1 V1, and here U1 V0, and here U0 V0, and that should be it. Let me think about it. Yeah, that should be it. For adding textures, and in the main, we have to set it up in subchunk here, mesh template, and we can simplify it. We can create a function. Okay, it doesn't matter. Let's do here mesh template. We need to set up the UVs here. So what were their names? What were the names of the UVs? Where are they? Cube mesh template header file. North, yeah, and the origins as well. The origin will be the same on all sides, so we can simplify it. We got a chatter. You've been live for 6-7 hours. I can't believe your determination success. Well done. What is your Discord? I don't have a Discord. I deleted it because it was distracting me from progressing, and I deleted it. This is an ancient word, man. Skype. So ancient. Didn't like Skype move to Teams? Skype is ancient. Man, I remember Skype. Good times. Void set UV origin vector to origin, and let's implement it. This is for when all of the origins are the same, which is a lot of the times. These origins here, and why didn't it copy them? Like this, like this. Origin. Like that. And so inside of the main, this will save us some time. Now inside of subchunk here, set UV origin to be, let's look at that sprite. And we'll use the dirt texture, so 32.0. 32.0. And 0016 should be the other thing. I think. Let's look at one example. Let's look at an example. Yeah, 0016. We can make a function for that to simplify. Can make a function. Void set UVs vector for UVs. This is when they're the same. This is when they're the same, which is most of the time, probably. we copy this here and we delete it. Equal UVs. Like that. And so in subchunk mesh template set UVs 0, 0, 16, 16. That should be it. And we need to change the main texture. We need to change the texture to be, instead of generating the image, to actually get it. To the engine sandbox. Let's look at CMake. Let's make a folder, resources, textures, and copy from the Java project. Open in Explorer, textures. We'll copy both the Atlas and this. We need Atlas PNG. And let's open another Visual Studio because we need reference. But from where? From where? Voxel engine. Do we have here? To the engine sandbox. Portable Churn OpenGL Unity. H3D test. No. Bunny. No. Build. No. Minecraft clone. Playable Minecraft. Voxel engine. No. Game prototypes. Maybe. Game prototypes. Does it have a CMake? Oh god damn it. No. Doesn't matter. If you start a live stream next Saturday, Sunday, can I play Minecraft on your server with you? I can set up the server. I do have Minecraft. But what are we going to do in Minecraft? I don't... most of the time I'm coding on my Minecraft clone. Here, how to Raylib read image from file. I need to get access to it. I need access to it. Image loading. Image, load image, this is what we need. Main image. I need to, it's from resources, textures, Atlas, PNG. Does it work? I need Raylib. I need Raylib for sure. We need Raylib to see what's going on. No. Okay, what's going on? Tell me, doctor. Let's look at the draw. Highlight draw call. Okay, and for this draw call, what's the pipeline? Mesh viewer. The mesh is fine, sure. Do we have a texture? No resources. It couldn't find the texture. And why didn't it tell me it cannot find it? Load image. Load image. Resources, texture. Can I do... Yeah, there was a command. There was a command you can do in CMake. YouTube.com low level game dev. There was this YouTuber that has it, and our craft maybe in his CMake. Where is it? It's for getting resources. Yeah, resource path. This is what I want. Project name, game, resource path. It's resources, and so we need to use it here like this. And so like this, textures, right? Textures and Atlas PNG. Does it work now? Yo! We have dirt. We have dirt. Yo! We can make it into grass. It's a bit pixelated. We can make it into grass. Subchunk here. We should change the mesh template. Top UV origin to be to equal. Where's the grass? Here. No, it should be the top. 0, 0. And this is the top. And we'll have to do the same for the sides. North, south, east, west. This is for the bottom UV origin. This is for the bottom. This is the bottom. This is the top, and this is the side. Where is it? This is the side 480. 480. Like this. Yeah, we have grass in Raylib. Man, this was so much work. This was so much work. Man, this was so much work. If you start a light, okay, never mind. Okay. Yeah, this was so much work. And yeah, I have the rendering the grass in Raylib in C++. It's not generating MIP maps, I think. But it's pretty cool. And it doesn't have ambient occlusion. Maybe we can add it. Generating grass blocks using Atlas texture. Next, I need to look at MIP maps. So what you call it? Raylib generate MIP maps. Oh, I need to give it a reference. Let me look at it. I can feel there's an issue with the MIP maps. I can feel it. Let's comment this out. Yeah, I give it a reference. Atlas. Give it a reference. Load image. Unload image, yeah. Generate MIP maps. But why is it not generating? Let's look at the console. Yeah, let's look at the console. This is for when it's uploading the mesh. Let's look at texture loaded successfully. Default texture load successfully. Shaders compiled. Texture load successfully. Graph. And this is my Atlas. MIP maps generated automatically. Total 9. It's generating MIP maps. No issue. But why is it still fuzzy? Maybe there are some other options we can try. Maybe there are some other options. Here, MIP map. Image MIP maps. Compute all MIP map levels for a provided image, but this is for an image. So even before the texture. So image MIP maps Atlas. Reference probably. Image MIP maps. Interesting. Why does it have one for image and another for the texture? And why is it now not loading? Why is it not loading? Let's close it and let's generate MIP maps for the image. Yo! But now it's as if it has changed the... It has changed the from point to linear for some reason. Atlas, format, MIP maps, MIP map 4, and here MIP map 4. Image format. Generate GPU MIP maps for a texture. Yeah, let's look at Raylib image format linear image generation. God damn it. Raylib, texture, format, point, linear. Oh, come on, man. Why isn't there much documentation on these things? Image has format, pixel format, has mip maps, width and height. Okay, let's look at pixel format. Let's look at pixel format. Pixel format. No, we don't care about this. We don't care about this. What about image? Yeah, what does this do actually? MIP count. Get pixel data size. MIP maps. If it's lower, but it's not. MIP maps already available. Okay, sure. Image copy. Oh, we are doing the MIP maps on the CPU probably. That's the difference. So let's remove this and see difference. Yeah, no. This is if I don't touch anything. And here it's if I generate MIP maps. Not that much of a difference. It's as if it's not generating MIP maps. Raylib model MIP maps. Set texture filter. Set texture filter. So set texture. Oh, filter. Texture. Filter. Filter. Anisotropic. Bilinear. Point. And what if I bring back this? Bring back this and this. Yeah. Now we have MIP maps. The issue is at the distance, it's not setting a limit to the MIP maps. It's not setting limit to the MIP maps. Raylib mip map limit. Oh, so should it be like lower number? No, it's the same. 2. Is the same. I just want a limit to the mip map. I know in OpenGL you can do it, but I don't know if Raylib will allow me to do it. In OpenGL it's extremely easy for the mip map level. Just need to go inside of texture, and inside of here I just do this. Texture max level. Can I do it here? Raylib. Texture. What if I increase it? What if I increase it here to more? 5? If it does any difference? No, it's the same. I want to limit it. Image mip maps. Mip count. Count mip map levels required. Let's put a... Can we put a breakpoint? Probably not. Yo, we can put a breakpoint in Raylib. Mip count is 9! 9! 5. I've set the limit. I want the limit to be 4. 9. Step over 10. Step into 11. Okay. Do I use this somewhere? Up to mip count. Okay, so here it goes from 1. Sure. And then the other one. 4. And now it's at 5. And here I stop. It should have stopped. Now this is 6. Oh. It will ignore the first 4, which is the opposite of what I want. It's the opposite of what I want. It's the opposite. Can I change the code? So this limit is 4 and this starts from 1. 1, 2, 3, 4. So if it's more than 4 to continue, can I do that? And to go back inside of the main, and here limit to 4. Oh, the breakpoint. God damn it. Here I've told it if it's 1, this is 4, 1 is not more than 4, should continue. So here it should tell me that it's generating them. It should say log debug. I want the debug. Okay, let's test it out. Here, the trace. Log debug. I don't get the debug. I don't get it. It's just info, no debug. Let's go back. Main. Let's ignore this. Yes. But yeah, for those MIP maps 5, 6 and up to 9, I haven't generated an image and it broke a bit. Yeah, I'll remove this. I'll go back to the Raylib code here and yeah, I'll bring it how it was before. Yeah, I changed the Raylib code to not create MIP maps for after MIP map 4, to not create MIP maps, but then when it came time to render, it still, like, a limit needs to be set. Does it use anywhere OpenGL? Can't I do when I create the texture? Set texture filter texture up, set MIP map, image MIP maps, and generate texture MIP maps. God damn it. I don't have access to that. What about this function? Or can I use this somewhere? I cannot use it here. What about here? No. Where is this? Vendor Raylib. Vendor Raylib. Examples. Raylib. Source. Yeah, I don't know, man. What about when creating a texture? Load texture from image. No. Loud texture here. Yes. Yes, here I can probably make changes. And can I look for this anywhere in the project? This is in glfw here. Define maximum number of mipmap levels to be used. 0 is base texture size. Where is this? Mipmap count. Mipmap count. So where is this? Loud texture. Loud texture. And what do we use? Main. Loud texture from image. This is different. Loud texture, mipmap, image mipmaps. Yes, sure. And here for me it's 4, right? The image mipmaps, sure. Atlas mipmaps equals 4. And here, let's do a breakpoint. And let's go inside. Mipmap, why is it 0? Now it's 1. What? Image? Let's do it again. Oh, maybe this for another image. This for a different image. I want it here. Here. This should be... Mipmaps is 9. But I set it to 4. I get it. Image mipmaps. Image. The default is 1. The default is 1. Oh, it changes it. It changes it. So I'll do it afterwards. And let's see if this changes stuff. Yes. Is this it? This should be it. Let's go to here, here, and the cool thing is I can make changes to Raylib and to actually go to the OpenGL code itself, and I can make changes to the OpenGL that is being called. Here. So let's go here and let's go here and here, and let's see if we reach here. Yes, we reach here, and this is 4 minus 1 equals 3. So I should set it to 5. I should set it to 5. Here it should be 5. And this should improve it more. Yeah, let's call it, like, let's leave it at that. At least it's not fuzzy. Do we continue or not from here? Do we do here generate texture mipmaps? Yeah, it's actually perfect now. Yeah, it's perfect now. Now it's perfect. Now it's perfect. Yeah. Do we continue? What do we do here? Should I implement a player? Should I do ambient occlusion? Or do I leave for tomorrow to have something to do? If I do a stream tomorrow, what it would be? I don't know. Maybe infinite terrain. We'll see. Yeah, this will be it for the stream.